November 3rd, 2025. On the surface, it feels like any other night. The stars are in their familiar places, the moon drifts in its silent rhythm, and the cold air carries the same indifference it always has. Yet for those who know where to look, this night is unlike any humanity has ever lived through. A faint emerald glow, invisible to most, is slicing its way across the heavens. It is not a comet from our Oort cloud, nor an asteroid chipped from Mars or Jupiter. It is 3I divided by Atlas, an interstellar wanderer, a stranger born under a distant sun, crossing our cosmic front yard. Pause for a moment and picture this. The quiet before a firework ignites, that suspended heartbeat when your body knows something immense is about to happen. That is the feeling scientists carry tonight. Telescopes across the globe are trained, not on the moon or the planets we know, but on a visitor that does not belong. Twice before, humanity was granted such an audience. In 2017, Oumuamua tumbled in like a splinter from another world, defying gravity in ways we still cannot fully explain. In 2019, Borisov came roaring through, trailing gases our solar textbooks never predicted. Both came and went like shadows on the wall, brief, elusive, and maddeningly silent. But tonight is different. 3I divided by Atlas is closing in, lingering longer, and carrying with it puzzles that no human generation has faced. Imagine standing on the shoulder of a highway, a foreign car streaking past with headlights you have never seen before, an engine note that doesn't match anything built on Earth. That is what this moment is. The rush of something alien speeding by, close enough to shake the ground of our understanding, far enough that we cannot touch it. The tension is not fear, but something sharper, intellectual suspense. The kind of unease that makes your chest tighten when you realize the rules may not be what you thought they were. Scientists describe it clinically uncertainties in orbital data, unexpected ratios of carbon dioxide to water ice, acceleration values that don't add up. Yet beneath the numbers, a more human feeling pulses. Awe, anxiety, the sense of standing at the doorway to a mystery older than our civilization. We are not afraid of 3I divided by Atlas in the way a sailor fears a storm. We are awed by it in the way a poet fears silence, that unbearable space where the next word might change everything. And then there are the 3 hypotheses, looming like storm clouds on the horizon. The first, 3I divided by Atlas, is a natural comet, albeit one forged in the crucible of a star system, utterly unlike our own. This scenario comforts us. It means the universe is strange but still plays by rules we can eventually decipher. The second, it may be artificial, or at least partially shaped by intention. A shard of technology cast adrift, the ghost of another civilization's ambition. This idea unsettles us not because it screams danger, but because it whispers possibility. To admit it is to admit we are not alone in seeking the stars. And the third, perhaps it is neither solitary nor engineered, but a fragment of something larger, a remnant from a cosmic catastrophe that shattered worlds far beyond our sight. A single shard making its way to us across eons, bearing silent testimony of destruction we can scarcely imagine. Each hypothesis pulls us in a different emotional direction. Each demands a courage not of the body, but of the mind. And as the clock ticks into November 3rd, with Mars drifting somewhere nearby in its red orbit, the questions sharpen. Are we watching an ordinary comet behave in extraordinary ways? Or are we staring at the first undeniable evidence that intelligence is not unique to Earth? Or worse or better, are we merely glimpsing the debris of a war or collision so vast it renders human history microscopic? The sky offers no answer yet. It only offers silence, the kind of silence that makes you lean forward, straining to hear what comes next. The stars are steady. The instruments hum, and across that fragile line between what we know and what we fear to know, 3I divided by Atlas passes, indifferent to our awe, relentless in its course. If the first glimpse of 3I divided by Atlas was a spark, tonight it has become a flame no one can look away from. Its emerald coma stretches like a ghostly veil, a reminder that we are staring at chemistry birthed under another Sunday. To most, the night sky looks unchanged, familiar constellations, planets wheeling in their timeless arcs. But for those who know what hangs in the dark, this is not routine, this is intrusion. Something from elsewhere has entered our stage, uninvited yet impossible to ignore. Consider what it means to watch such a thing from Earth. We are tiny, tethered by gravity to our one fragile sphere, and yet our instruments can trace a visitor born billions of miles away. This ability fills us with pride, but also with unease. Because the closer we look, the stranger the questions become. Why is its acceleration so faint compared to the furious venting of its coma? Why does its chemistry read like a riddle, heavy with carbon dioxide where water should dominate? These are not quirks. They are challenges, tests that tug at the very edges of our scientific imagination. The air of November carries that dual edge, the excitement of knowing we are watching something no generation has seen, and the sobering weight that our models may not be enough. It is like watching a chess master across the table move a piece you've never seen before. Do you call it a mistake? Or do you admit the rules have changed? That is the intellectual pressure pressing down on astronomers tonight, and the hypotheses only deepen the tension. Suppose it is natural, an exotic comet sculpted by a star system rich in carbon dioxide ice, its structure warped by conditions unimaginable here. If that is true, then we are witnesses to diversity, a living reminder that worlds out there can produce chemistry as alien to us as oxygen once was to the early Earth. That alone is thrilling, but suppose instead it is artificial, something once designed, once crafted, even if only a fragment, even if only debris. What does that say about who or what launched it into the abyss? This is not science fiction anymore. The object is here, tonight, and we can measure it. The possibility is terrifying, not because it implies a threat, but because it shatters solitude. Humanity has always lived in the shadow of silence, telling ourselves we might be alone. What if tonight that silence cracks? Then comes the third hypothesis, the one most haunting of all, that 3I divided by Atlas is neither comet nor machine, but wreckage. Imagine a planetary system ripped apart in violence, fragments hurled into interstellar space like sparks from a fire. Imagine one of those sparks traveling across eons, across distances so vast they make centuries look like seconds, only to brush past our neighborhood in this precise moment of history. If that is true, then we are not witnessing a visitor so much as a relic, a piece of evidence from a crime scene written across the galaxy. And like detectives arriving too late, we are left with fragments, ashes, and questions we cannot yet ask in full. Each possibility is heavy. Each possibility stretches our imagination to breaking. And what keeps scientists awake tonight is not fear of catastrophe. 3I divided by Atlas poses no threat to Earth but fear of ignorance. Fear of watching it pass and leaving us no wiser than before. It is like standing before a locked door in a burning building, knowing that beyond it is either salvation or smoke, and that the key might slip from your grasp before you even try it. The night wears on, the data streams flow, and still the tension grows. Because the true question is not what 3I divided by Atlas is, but what we are, whether we are ready to confront a universe stranger than we hoped, darker than we feared, and more alive than we ever dared to believe. The clock strikes midnight, and still the world watches. November nights carry a special kind of stillness, the kind that makes you hear your own breathing against the backdrop of eternity. Yet tonight, that silence feels staged, like the hush before a jury delivers its verdict. For in that silence, an interstellar fragment arcs past Mars green, inscrutable and unbothered by the weight of our questions. It is easy to forget that just months ago, 3I divided by Atlas was nothing more than a faint blur on the outskirts of detection, a whisper of motion against the cosmic background. Now it is center stage, pulling our imagination taut as a bowstring. We are no longer asking if it is real, we are asking what its reality means for ours. The suspense has grown into something almost unbearable, because the universe does not pause to explain itself. The object moves, the coma expands, the sunlight refracts, and our questions multiply faster than answers can be found. Consider the first hypothesis again, the comfort of calling it natural. If it is a comet, then at least we are standing on familiar ground. The laws of physics still hold, even if they are stretched. Its carbon dioxide dominance, its subtle acceleration, anomalies, these become puzzles within a larger frame, curiosities that enrich rather than unravel our understanding. But to rest in this comfort is to ignore the shadows at the edge of the frame, because 3I divided by Atlas refuses to behave in neat lines. Its data resists easy fitting. Its signals tease outliers that mock our equations. Nature can be strange, yes, but how strange before natural becomes just another shield against the unknown. Now shift to the second hypothesis, the one that keeps philosophers awake. Artificial. The word alone tastes like lightning on the tongue. If even a fraction of 3I divided by Atlas bears the fingerprint of design, then the cosmos has just handed us a confession. We are not the first, not the only, not alone. Think of that. Every story we have told about isolation, every myth of human centrality would need rewriting. The idea does not terrify because it suggests invasion. It terrifies because it suggests kinship. Somewhere, sometime, another intelligence touched matter and shaped it. And tonight, that shaped matter glides across our solar system like a note slipped under the door of history. And then the third hypothesis presses in the spectre of wreckage. Imagine fire consuming a system, worlds colliding with such force that their fragments scatter into eternity. Imagine survivors, if there were any, watching their home become dust, knowing pieces would drift like cosmic orphans into alien skies. If 3I divided by Atlas is such a piece, then it carries grief older than our species, sorrow frozen into rock and ice, finally finding its way into our telescopes. To call that natural or artificial feels inadequate. It would be tragedy made manifest, loss turned into a trajectory. Each possibility sharpens the tension. To stand under the night sky tonight is to feel the weight of 3 doors before us, each leading into a different universe of meaning. Whichever door is real, once opened, cannot be closed. That is why the silence feels louder, why the air feels charged. Because we are not only studying an object, we are studying the edges of our own imagination. And so, as Mars drifts quietly in its orbit, red and indifferent, a more profound drama unfolds. 3I divided by Atlas cuts through the dark like a scalpel, dissecting not planets or moons, but our assumptions themselves. Scientists write equations, philosophers write questions. Ordinary people write their names into search bars, trying to glimpse the glow. And all of us, in one way or another, are standing at the same window, watching something foreign drift past, wondering if it will leave us changed. Dawn approaches, though the night feels endless. The calendar insists it is November 3rd, 2025, but time itself seems suspended. The earth turns, the moon wanes, and yet, for many watching, the world has narrowed to one truth. Somewhere out there, 3I divided by Atlas is moving, indifferent, unyielding, unstoppable. It does not care that billions of human eyes are searching for it. It does not care that equations strain to cage its trajectory. It does not care that our myths and fears tangle in its emerald light. It moves, because that is what it does, because momentum written across interstellar distances cannot be bribed, delayed, or denied. And so humanity watches, not with fear, not even with hope, but with a deeper sensation, an ache that sits somewhere between awe and dread. This is the ache of standing in front of a door we are not sure we want to open. What if, when the data resolves, the object is wholly ordinary, just another comet in an unfamiliar costume? Will disappointment crush the suspense we carry tonight? Or worse, what if the data whispers something that cannot be explained away? What if the signature of design lingers, undeniable? What if the debris of a shattered world stares back at us through the spectra? Both outcomes wound us in different ways. To discover we are alone leaves us smaller than we hoped. To discover we are not leaves us less prepared than we imagined. These questions give the night its weight. Astronomers process numbers, but ordinary people process feelings, and those feelings cannot be easily graphed. Consider the child, looking through a backyard telescope for the first time, told by a parent that tonight a stranger will pass close by. Consider the philosopher pacing the floor, realizing that millennia of thought may hinge on whether a green haze means chemistry or communication. Consider the skeptic, steady and unyielding, repeating to himself that nature is enough, even as the doubt gnaws at the edges. 3I divided by Atlas binds them all together. One visitor, one night, one fragile planet trying to decide what to believe. And the 3 hypotheses hang heavier than ever. The natural comet, the most comfortable but the least satisfying. It explains much, but not all. It keeps us grounded, but denies us the thrill of transcendence. The artificial shard, the most dangerous, because it challenges not our bodies but our egos. It forces us to see ourselves as young, provincial, and naive in a cosmos filled with older engineers. The fragment of catastrophe, the most tragic, because it tells us that even stars give birth to systems that die, that even civilizations might scatter their ashes across infinity. Each path is unsettling, each path is profound, and none can be chosen tonight. In this way, 3i divided by Atlas is not just an object, it is a mirror. It reflects the stories we tell ourselves about the universe. Some see it as a comet because they crave stability. Some see it as a probe because they crave connection. Some see it as wreckage because they understand loss. And all of them, in their own way, are right. Because what matters tonight is not what the object is, but what it makes us become while we stare at it. The green glow fades from view as dawn bleeds into the sky, but the silence remains. For those who watched, November 3rd will not pass into memory as just another date. It will linger, stitched into the fabric of personal time. People will say, "I was there, awake, when a messenger from another sun swept past Mars." They will not all agree on what it means, but they will agree that it mattered, because sometimes history is not about what happens on Earth. Sometimes it is about what drifts past, silent, uninvited, and unforgettable. And so part 1 closes, not with answers, but with questions sharpened like blades. Was this the face of nature at its strangest? The echo of intelligence across light years? The scar of destruction from a war or collision too vast to imagine? Whatever it was, the world will carry the tension forward into the next act of this unfolding story. For now, we are left with the silence of the sky, the hum of our instruments, and the echo of 3 hypotheses that refuse to rest. November 3rd, 2025. The night sky looks ordinary from Earth, stars, constellations, a faint haze at the horizon, but tonight, our truest witnesses are not here. They are hundreds of millions of miles away, circling a desert world that has never heard a human voice. Above Mars, old orbiters sweep their endless paths in silence. Machines built long ago for missions far less glamorous. Their cameras were meant for dust storms, their spectrometers for studying the thin air, their antennas for mapping canyons and craters. But fate has a way of surprising us. Tonight, those same orbiters, outdated, aging, almost forgotten, have been handed a task no one could have scripted: to stare outward, away from the planet they serve, and record the passage of 3i divided by Atlas, the alien wanderer that now cuts across their sky. It is a scene almost cinematic in its irony. We built these orbiters to look down, not up. They were gardeners tending a lonely red world, cataloguing soil and sand, measuring ice caps as they waxed and waned with the seasons. Yet tonight, they have become astronomers by accident. The gardener, pausing in his labor, has spotted a fireball streaking overhead, a fireball that might redefine the history of astronomy. That is what this feels like, an accidental miracle, where the very tools designed for one story suddenly illuminate another. Picture it. An orbiter drifts silently in the black, Mars glowing beneath like a dying ember, dust storms swirling faintly in the thin air below. Beyond, among the hard stars, a smear of green slides into view. No sound, no movement, felt just the faint whisper of light through a detector. Photons that have traveled for countless years, only to die on a sensor the size of a thumbnail. Those photons carry secrets. They speak in the coded language of spectra, in the subtle variations of brightness, in the shimmering expansion of a coma that should not exist in such form. They arrive without fanfare, but each one is a key, and together they might unlock a truth about what this object is and what it means. And here is where the feeling changes, from passive awe to active tension. Because this is not a spectacle to be applauded like fireworks. This is an experiment, one chance only. Orbiters around Mars cannot blink, they cannot fumble, they will never have this perspective again. If they miss a moment, it is lost forever. From Earth, the view is muddied, atmosphere smearing the faint glow. But from Mars orbit, geometry is everything. The sunlight strikes at an angle impossible from our line of sight. The coma spreads asymmetrically, revealing layers invisible to ground-based telescopes. It is the difference between watching a parade from the sidewalk and flying overhead in a helicopter with a 360-degree camera. You see patterns invisible from below, formations, symmetry, subtle deviations. This is why the orbiters matter. They are not just silent witnesses, they are unique witnesses, and perhaps most poetic of all, they wait with us. They circle and circle, never hurrying, never slowing. Machines of patience, humanity, on Earth, paces, refreshing live feeds, speculating, debating. The orbiters simply watch, They absorb photons, transmit packets of data, and accumulate the testimony of an alien traveler. They do not share our anticipation, but they embody it. They are the stillness to our restlessness, the patience to our desperation. In them, we project our hope that when the data comes home, it will not be noise, not be emptiness, but clarity. Tonight, the orbiters above Mars are no longer relics of old missions. They are history's cameras, turned at the perfect angle, in the perfect place, at the perfect time. No human set foot on Mars to witness this, but our machines have done it for us. They are the unblinking eyes staring into the dark as a stranger drifts past. They are the librarians of silence, writing a record no one else could write. And when dawn comes on Earth, when headlines scramble to catch up, these orbiters will still be there, circling in their tireless rhythm, having captured something we could never have seen without them. Why does the Martian vantage point matter so much? To understand it, imagine two people watching the same event from different seats in a stadium. One sits in the front row, directly behind the players. The other watches from high above, across the entire field. The first sees sweat and grit, the second sees patterns and plays. Both are true, but the second reveals a strategy invisible from the ground. That is what Mars orbiters offer us. Not a closer view, but a different geometry, a perspective that rewrites what the event looks like. From Earth, 3i divided by Atlas appears as a faint streak tangled in our atmosphere's distortion. Our telescopes battle turbulence, dust, and the sheer flattening of distance. Even the best instruments blur, their vision like a camera shooting through rippling heat on asphalt. But from Mars orbit, the view is crystal clear. There is no heavy atmosphere to scatter light, no ground vibration to rattle the detectors. The orbiters float in silence, receiving photons in their purest form, clean lines against a black canvas. For science, that purity is priceless. Every degree of scattering stripped away means sharper spectra, more accurate albedo measurements, and more reliable light curves. But geometry is more than clarity, it is an angle. As 3i divided by Atlas slips past Mars, the sunlight strikes it differently than it does from Earth. Phase angle, astronomers call it, the angle between the light source, the object, and the observer. Change that angle, and you change what you see. It's like holding a glass marble under a lamp. On one side, it glows softly. From another, sharp reflections blaze out, tiny rainbows scatter, and cracks within the marble become visible. From Earth, we see one version of 3i divided by Atlas. From Mars orbit, we see another, and the second version may hold clues that the first never reveals. Consider the coma, the vast, ghostly envelope of gas and dust surrounding the nucleus. From Earth's viewpoint, much of that coma overlaps itself, a fog we cannot disentangle. From Mars, the coma stretches at a different angle, layers peeling apart like sheets of silk. Instruments in orbit can watch how light dims as it cuts through the cloud, mapping density gradients invisible from below. If jets of gas erupt asymmetrically, little geysers of carbon dioxide, Mars orbiters might see them edge on, like watching smoke drift across a window pane. From Earth, those same jets vanish into the blur. Or take albedo, the measure of how much light the surface reflects. From Earth, 3i divided by Atlas is a point source, a blinking dot smeared by coma. From Mars orbit, subtle changes in brightness reveal rotation, shape, and even surface texture. It is the difference between staring at headlights on a highway and lifting into a drone view, suddenly seeing the curves of the car, the shimmer of its paint, the way dust trails behind its tires. For a visitor like this, where every photon matters, that shift is enormous. And then there are occultations, moments when 3i divided by Atlas passes in front of stars from the Martian perspective. From Earth, those alignments are rare and poorly placed. But from Mars, the geometry shifts. A faint star blinked out for a second can reveal the width of the coma, the density of its tail. A blip in brightness can outline a nucleus that remains invisible otherwise. These fleeting alignments, impossible for us to catch from our home planet, might fall directly into the detectors circling Mars. For astronomers, such accidents are a treasure. The orbiters themselves, though silent, seem to embody patience. They do not feel awe, but we project it onto them. Imagine their cameras turning, tracking, holding the stranger in frame as Mars spins below. Each photon that lands on a sensor is like a bead of rain in a desert, rare, precious, telling. The people on Earth know that this geometry will never come again. Mars will not host another interstellar visitor in the same configuration within our lifetimes. Miss it, and the data is gone forever. That is why this vantage point matters. That is why the world waits. And so, the silent witnesses are not just passive observers. They are bridges across geometry itself, giving us the one thing science craves most: a second angle. Without it, we have a flat picture, like a coin held face on. With it, we glimpse the thickness, the edge, the hidden relief. We gain depth. Tonight, as 3i divided by Atlas sails past Mars, it is depth we seek, not just in images, but in meaning. And only the orbiters can give it. What exactly are these silent witnesses measuring? It is tempting to imagine them as cameras alone, snapping pictures of a glowing blur. But orbiters are far more than cameras. They are laboratories drifting through emptiness. Each one carries instruments that, when pointed at 3i divided by Atlas, become extensions of human curiosity. They are our eyes, yes, but also our ears, our sense of smell, our fingertips pressed against a mystery no human hand will ever touch. First, there are spectrometers. These instruments break light into rainbows, revealing fingerprints of molecules. When 3i divided by Atlas flares, its coma glows in wavelengths far beyond the visible. A spectrometer can tell whether that glow comes from carbon dioxide, water vapor, or more exotic ices like carbon monoxide and methane. Imagine holding a glass of water to the sun and instantly knowing whether it was mixed with salt, sugar, or poison. That is what a spectrometer does. For 3i divided by Atlas, the ratios matter deeply. If carbon dioxide dominates, it means the comet formed in a frigid nursery unlike anything in our solar system. If exotic gases appear, it could mean conditions stranger still, chemistries we have never seen, perhaps never imagined. Next, come photometers and albedo sensors. These are less glamorous, but no less crucial. They measure brightness, the way sunlight bounces off dust grains and ice crystals. From changes in brightness, we can map rotation, detect if the object tumbles, and even estimate its shape. It is like watching the sparkle of a coin flipped in the air. From the glint pattern, you know how fast it spins, how flat or rounded it is. Orbiters can detect those sparkles better than Earth, because the angle is sharper, the background cleaner. And for something interstellar, those details could reveal whether the nucleus is jagged, smooth, or fractured, each clue pointing back to its origin. Then there are light curves, the careful records of how brightness changes over hours and days. From Earth, we try to build these curves, but clouds and atmosphere break the continuity. From Mars' orbit, the sky is always cloudy, and the data never breaks. Every dip and swell in the curve reveals behavior. Is the coma expanding steadily? Are jets firing intermittently? Is there a rhythm that suggests rotation? A light curve is not just numbers on a graph. It is a pulse, a heartbeat. To chart it is to feel the rhythm of a stranger from another star. And we cannot forget imaging systems, sharpened by decades of practice photographing Martian valleys and cliffs. Turned outward, these cameras capture frames of 3i divided by Atlas against the black. Though faint, though distant, those images can show the coma's structure, the direction of the tail, the subtle asymmetry that might betray something unusual. Think of fog lit by a street lamp. From some angles it looks uniform. From others, wisps and eddies appear, telling you where the wind blows. In the same way, images from orbit reveal whether the comet is venting symmetrically, or if hidden forces tug it off balance. Finally, there are occultation sensors and star trackers, devices built to navigate, but repurposed for discovery. When 3i divided by Atlas passes in front of background stars, even for an instant, those instruments record how starlight dims. That dimming outlines the coma, like tracing the silhouette of smoke around a candle flame. On Earth, such alignments are rare. From Mars, they might be common. Each blink is a revelation, another piece of the puzzle. The remarkable thing is how ordinary these instruments seem. None were designed for interstellar encounters. They were meant for dust, storms, thin air, yet tonight they become humanity's only bridge to another system. It is like discovering your old pocket knife, carried for camping trips, can also unlock a vault you never expected to find. The orbiters are not specialized telescopes, not billion-dollar observatories. They are workhorses, versatile and patient, and that is their strength. As data streams down, the anticipation grows. Somewhere in the rain of photons, in the flicker of brightness, in the blink of a hidden star, lies the truth of what 3i divided by Atlas really is. Scientists do not expect fireworks. They expect subtleties, ratios, slopes, patterns, and yet the excitement is fierce, because subtleties change everything. A single anomalous ratio could hint at chemistry never seen before. A single irregular glint could hint at a shape inconsistent with nature. A single occultation could reveal a coma denser or wider than theory predicts. Each small detail is a hinge, capable of swinging open doors to ideas far larger than the detail itself. So the orbiters record. They do not shout, they do not speculate, they measure. They turn alien photons into numbers, numbers into graphs, graphs into questions. And while they do, the rest of us wait hungry for each packet of data, each whisper from machines circling a world we have never walked upon. The orbiters are our patience embodied. They are the calm hand steadying the telescope while the heart races behind it. What makes this vigil so extraordinary is not only the uniqueness of the vantage point, but the stakes of interpretation. Every bite that trickles back from Mars is a gamble. Will it clarify the puzzle of 3i divided by Atlas, or deepen the riddle? Scientists know the risk, and that knowledge keeps their excitement tethered with caution. Because data is not truth, it is raw clay, waiting to be sculpted, vulnerable to misreading. The orbiters can deliver unprecedented clarity, but clarity is dangerous when it tempts us to see what we want instead of what is. The first challenge is expectation itself. Many hope the data will finally rule out the wildest scenarios, banishing whispers of artificial origin or cosmic wreckage. Others secretly hope for the opposite, that something unexplainable will survive the gauntlet of analysis. This tug-of-war between skepticism and wonder is not new. It defined our reaction to Oumuamua and Borisov too. But with 3i divided by Atlas, the tension is stronger, because this time we prepared. We positioned orbiters, pointed instruments, and anticipated the flyby with a readiness our predecessors never had. The expectation feels heavier, precisely because our tools are better. Failure to learn something transformative would sting more than ignorance ever could. Then there is the technical challenge. Orbiters are versatile, but they are not designed for this role. Their detectors may saturate if the comet flares too brightly, or struggle if it dims unexpectedly. Their pointing systems, optimized for Mars, must track a moving target at interplanetary speeds. Imagine using a smartphone camera, designed for family portraits, to photograph a lightning bolt possible, yes, but filled with risk. Even the slightest misalignment could ruin an observation, and there will be no second chance. The engineers who once designed these systems never imagined they might hold the key to unraveling an interstellar traveler. That irony adds both charm and terror to the mission. Another challenge is time itself. The geometry of the encounter lasts only days, with the sharpest angles confined to hours. After that, 3i divided by Atlas will drift on, and Mars will no longer be in position to catch its secrets. It is like trying to read a message scrawled on a train as it roars past your station. You have seconds to capture the words, miss them, and the train is gone forever. For this reason, scientists pore over schedules, simulations, and error budgets, knowing the smallest oversight could mean silence where there should have been a signal. Yet, for all these risks, the potential reward is staggering. A clean spectrum could redefine what we know about planetary formation in other systems. A sharp light curve could settle debates about the comet's size and density. A well-timed occultation could reveal the coma's true reach. Each dataset is more than information. It is leverage, tilting the balance between competing theories. It is as if we stand before three locked doors: the natural comet, the artificial shard, the wreckage fragment, and the orbiters may hand us the keys to one. But even here, humility is required. Scientists know that no single dataset will end the debate. A spectrometer might scream carbon dioxide, but skeptics will remind us that abundance alone proves nothing. A light curve might hint at tumbling rotation, but interpreters will caution that natural fragments tumble too. Evidence does not speak in headlines, it speaks in careful, hesitant whispers. And so, the greatest challenge may be patience, not in gathering the data, but in resisting the urge to overclaim. Humanity is desperate for answers. The orbiters will give us glimpses, but glimpses are not revelations, they are beginnings. Still, the excitement remains irrepressible. Somewhere, perhaps tomorrow, a graduate student will open a file from Mars, expecting noise, and instead see a pattern that changes everything. Somewhere, a team will overlay their light curve with Earth's, and suddenly realize the inconsistency that forces a rewrite of the models. These are the moments scientists live for, the quiet miracles of analysis, when raw numbers blossom into insight. And all of it stems from the silent watchers circling a world we have not yet walked. For now, we balance expectation with caution, hunger with restraint. We wait for photons to turn into numbers, for numbers to become questions, for questions to carve paths toward truth. The orbiters hold their vigil, patient as monks, and we, restless on Earth, can only wait with them. This is the paradox of discovery. The closer we come to answers, the more fragile our certainty feels. And that fragility, that trembling balance between hope and humility, is exactly what makes tonight so unforgettable. When the story of 3I divided by Atlas is told years from now, historians may not dwell on the numbers or even the comet itself. They may instead remember the strange poetry of this moment. Machines we had nearly forgotten, orbiting a planet no human has touched, becoming the sole witnesses to a once-in-a-civilization encounter. That irony alone is enough to stop you in your tracks. For decades, Mars orbiters have been like quiet archivists, collecting dust storms and surface maps, filing them away without fanfare. And now, suddenly, those same archivists are handed a page from a book no one thought they would ever see. The chapter where the universe sends a messenger from another star. The significance is not only scientific, it is cultural. Every civilization longs for connection, for evidence that it is not alone in the dark. And though tonight may deliver nothing more exotic than strange ratios of carbon dioxide and water, the act of watching matters. We built eyes around another planet, and those eyes looked outward instead of down. That shift alone, the moment when we turned our tools away from ourselves and toward the cosmos, is historic. It marks a threshold, a declaration that humanity's curiosity has grown too large to be confined to its own neighborhood. But this is not a triumphal story. It is a story of patience, humility, and restraint. The orbiters do not give us a cinematic live stream. They do not beam down dramatic images of glowing emerald comets streaking by. They return files, packets of data, lines of spectra, and curves of brightness. The beauty lies not in spectacle, but in process. Humanity's challenge is to find wonder in those curves, to translate columns of numbers into meaning. It is slow work, requiring discipline. In that sense, the orbiters are not just silent witnesses, they are teachers, reminding us that the universe yields its secrets only to those who are patient enough to wait. There is also something deeply unifying about this vigil. Across Earth, people of every language and culture refresh screens, scroll news feeds, whisper about the comet from another star. Few will ever see the raw data, and fewer still will analyze it. But all of us participate in the waiting. We share the knowledge that something alien is passing by, and that our machines, far away, are catching its faint glow for us. In an era when the world feels fractured, this shared anticipation is rare and precious. It is as if the entire planet has paused for a single breath, united by curiosity, and that unity extends forward. Because the data from Mars will not end the story, it will begin new ones. Some results will confirm expectations, others will confuse, contradict, or provoke. Entire careers may be shaped by anomalies detected this week. Books will be written, theories tested, instruments built anew. The legacy of these silent witnesses will ripple across decades, long after their circuits fade. They may burn up in Mars's atmosphere one day, or lie cold and forgotten in orbit, but their testimony will endure in the papers, the debates, the discoveries seeded by the data they gather now. In this way, the orbiters embody something more profound than machines. They embody our hunger to know, our willingness to wait, our capacity to build tools that outlast us. They are extensions of our patience, of our stubborn refusal to accept ignorance as final. Tonight, as they circle Mars, they do what we cannot. They keep still eyes on a passing wonder, unblinking, tireless, and we, millions of miles away, borrow their gaze. So part 2 closes with a paradox. The orbiters themselves are silent, lifeless metal. Yet through them, the universe speaks, not in words, not in shouts, but in the language of photons and shadows, spectra and curves. They tell us that 3I divided by Atlas passed, that it glowed, that it left its mark on our instruments. They cannot tell us whether it was a comet, a craft, or wreckage, That will be our work in the months and years ahead. But without them, we would have nothing at all. They have given us the gift of perspective, the gift of patience, the gift of time frozen into data. And somewhere beyond, 3i divided by Atlas keeps moving, never pausing, never caring. The orbiters, faithful to their circuits, will soon turn back to their old duties, measuring dust and thin air. But for these few nights, they became history's cameras. They became the witnesses no one else could be. And as the echoes of their measurements reach Earth, humanity prepares for the next question, the next challenge, the next part of a story that grows stranger with every passing hour. Imagine standing in front of a chalkboard filled with equations, only to realize that no matter how you rearrange the symbols, the numbers refuse to agree. That is exactly what 3i divided by Atlas has become in mid-November 2025, a moving paradox written across the sky. By now, the first round of observations from Earth and from deep space telescopes has been logged, filtered, and compared. The results should be converging. Instead, they split wide open. Brightness estimates don't match mass estimates. Comet activity doesn't match acceleration. It is as if the universe handed us a puzzle box but swapped out half the pieces with ones from another set. The picture is supposed to be a comet. Instead, it looks like something else, something we cannot quite name. The hook here is simple. Comets are supposed to behave. We have formulas for them. We know how solar radiation turns ice into gas, how jets erupt from their surfaces, how light curves reveal size and spin. We have watched dozens up close, even flown spacecraft through their comas. By those standards, 3i divided by Atlas should be predictable. Yet it resists. It follows the broad strokes of cometary behavior. Yes, it has a coma. Yes, it brightens as it approaches the sun. But the details refuse to line up. It is not chaos, it is contradiction. That is far worse, because contradiction means either our data is wrong or our understanding is. And the more carefully scientists check, the more they suspect the second. The first contradiction lies in size. Based on visual magnitude and coma brightness, some calculations put the nucleus at barely 300 meters across, smaller than a city block, a pebble, by cosmic standards. But thermal models, derived from the faint heat signature in infrared, suggest something several kilometers wide, perhaps 5 or 6 kilometers, a chunk of ice and dust large enough to swallow a metropolis. The spread is absurd. Imagine trying to measure a stranger's height in a crowd. One ruler says 4 feet, another says 12. Both can't be true. Yet both arise from valid methods, carefully applied. With 3i divided by Atlas, this is no longer a statistical hiccup. It is a split personality. Then comes the coma itself. Ordinarily, a coma tells you about the nucleus that feeds it. A small body with such a bright and extended envelope should have burned through its resources long ago. A large body should sustain one easily, but its coma ought to be denser, more massive, brighter still. Instead, 3i divided by Atlas offers a third option. A coma that is ghostly yet persistent, luminous yet insubstantial, clinging to an object that seems too small to support it and too big to explain its delicacy. Astronomers run the numbers again, and the sums still refuse to match. The contradiction sharpens when scientists calculate density. If the nucleus is small, its activity implies impossible efficiency, as though every grain of ice vents perfectly, non-stop, without loss. If it is large, its coma suggests the opposite, that most of its surface is sealed tight, inert, unwilling to participate. Either way, 3i divided by Atlas behaves like a magician's trick. The hand gestures make sense, the props are familiar, but the result leaves you blinking, unable to spot the sleight of hand. This is why the mood around the object has shifted. It is not simply fascination anymore, it is frustration seasoned with delight. Scientists speak of it not with despair, but with a kind of incredulous joy, the way a mathematician might grin when a theorem resists proof. Because paradox is fertile ground, behind every contradiction lies the chance that something fundamental has been overlooked, something new waiting to be discovered. And so, as November rolls on, the object continues its silent journey, trailing a coma that whispers, "Figure me out if you can." The puzzle is not finished. It has barely begun. But already, 3i divided by Atlas has earned a reputation not just as a visitor, but as a question mark made visible in the night sky. If the size debate made astronomers uneasy, the issue of acceleration turned unease into open bewilderment. By all prior knowledge, a comet with a glowing coma behaves like a miniature rocket. As solar heat strikes its frozen surface, gases erupt in plumes, pushing gently but steadily against the nucleus, nudging its orbit in ways that we can calculate with confidence. These non-gravitational accelerations are not curiosities, they are textbook features. They are so common that mission planners to comets like Halley or 67P relied on them when plotting spacecraft trajectories. You expect them, the way you expect a kettle to hiss when water boils. Yet with 3i divided by Atlas, the hiss is deafening, and the kettle never shakes. The contradiction leaps from the data. Telescopes detect strong outgassing carbon dioxide venting in quantities large enough to generate an emerald coma, visible millions of miles away. Spectra show the signature clearly, images confirm the jets, and models predict the force. And yet, orbital calculations reveal almost no measurable deviation from the path gravity alone would prescribe. It is as if the cosmos staged a performance where smoke billows from an engine, the pistons pound, and the roar echoes across the valley, only for the vehicle to sit motionless at the starting line. Scientists reach for analogies, trying to explain the absurdity to themselves and to the public. One compares it to a fire hose spraying with furious pressure, yet the nozzle is fixed in place, anchored by some unseen hand. Another likens it to a boxer throwing punch after punch into the air, muscles straining, sweat flying, yet the bag never sways. The imagery may sound dramatic, but the science is precise. By all our equations, thrust should be there. And it isn't. Hypotheses multiply. Perhaps jets erupt on opposite sides of the nucleus, their forces cancelling each other in a precarious balance. It's a neat idea, but the symmetry required borders on impossible. Real comets tumble, venting unevenly. Getting a perfect cancellation every day, every orbit, is like expecting two dancers to spin on ice without ever falling out of sync. Another possibility is sheer inertia. Maybe the nucleus is far more massive than brightness suggests, a mountain of frozen stone whose weight swallows the thrust. But then its coma should be weak, not blazing. To solve one contradiction is to birth another. The frustration grows sharper because the paradox survives scrutiny. Measurement errors can be blamed at first, but repeated observations across instruments confirm the same result. The jets are real, the coma is active, the acceleration is absent. Each new dataset that should close the case instead drives the wedge deeper. Astronomers find themselves in that rarest of scientific moods, trapped between the certainty of observation and the impossibility of interpretation. And yet, there is delight in the trap. Because contradictions are fertile soil. Every major revolution in physics began with numbers that refused to behave. Mercury's orbit, pre-Einstein, blackbody radiation before quantum theory, pulsars, before neutron stars were imagined. In the same way, 3i divided by Atlas tempts with the possibility that we are staring at the beginning of something new, either a process of outgassing unique to interstellar chemistry, or a flaw in our assumptions so deep we never saw it. To be wrong, in science, is often the first step toward being right in a bigger way. Some suggest exotic mechanisms, perhaps gases vent into cavities within the nucleus, roaring in brightness, but delivering little thrust outward. Perhaps fractures spread in patterns that vent symmetrically by accident. Perhaps the ices are layered in ways that suppress momentum transfer. None of these satisfy fully, but each points toward chemistry and geology foreign to our solar system. And that is precisely what makes 3i divided by Atlas magnetic. It is not simply alien in origin, it may be alien in behavior, carrying rules we have yet to write down. By mid-November 2025, one phrase circulates among research groups: the paradox comet. The name is informal, but fitting. It moves as though only gravity matters, while flaunting a coma that screams of energy release. It plays by our rules in orbit, but breaks them in physics. And like all good puzzles, it draws us closer the more it resists. For every frustrated calculation, there is the gleam of possibility that the missing thrust is not an error, but a clue. Somewhere in that contradiction lies a secret, waiting for the patience and ingenuity to uncover it. If the contradictions of acceleration were not enough, the estimates of mass and density take the puzzle into even stranger territory. For comets, mass is never measured directly. We infer it from brightness, from coma activity, from orbital nudges. It is detective work, assembling clues from indirect evidence. Normally, the clues converge. With 3I divided by Atlas, they scatter like spilled marbles, rolling in every direction. The logic should be simple. A nucleus a few hundred meters wide cannot sustain the spectacular coma we see without exhausting itself. A nucleus several kilometers wide could, but then its coma should be thicker, brighter, and its acceleration far smaller. Instead, we observe something maddening, a coma that is both too vigorous for a small body and too faint for a large one. Neither possibility fits. It is as though you are handed a candle that burns like a bonfire but leaves barely any ash behind. The output mocks the input. Astronomers try to quantify the paradox. Using coma luminosity and outgassing rates, some calculations yield a lower mass limit of 30 billion tons, already immense. But when orbital stability is modeled under that assumption, the numbers strain credibility. Such a mass would be at the extreme upper boundary for Hubble's resolution. The object should look bulkier, should occlude stars more consistently. Instead, it flickers as if smaller. Shrink the mass, however, and the coma becomes impossible, too much gas pouring from too little ice. Once again, the math refuses to compromise. Density offers no relief. If 3I divided by Atlas is small yet still supports its coma, then its density must be fantastically low, almost foam-like, riddled with voids that let gases escape everywhere at once. But then how does it hold together over interstellar journeys lasting millions of years? Such a fragile snowball should have been shredded long before reaching our solar system. Conversely, if it is dense and massive enough to endure the voyage, its coma is inexplicably underpowered, like a furnace glowing faintly despite a mountain of coal. Both extremes stretch belief. Scientists liken it to weighing a suitcase by lifting it. One moment it feels light, the next it drops heavy in your hands. The scales give two readings, neither stable nor reconcilable. Something inside shifts every time you test it. That is 3I divided by Atlas, a cosmic suitcase whose contents refuse to settle. Speculation thrives in the gap. Some propose that interstellar comets may contain exotic structural matrices, ices laced with dust, that fracture in ways we have never modeled, producing extended comas without significant erosion. Others wonder if what we see is not one body at all, but a loose cluster of fragments bound weakly, venting collectively while masquerading as a single nucleus. Still others whisper about reflective shells or hollow cores, ideas bordering on science fiction but driven by the stubborn refusal of the data to align. And yet, beneath the frustration lies fascination, because contradictions force creativity. To reconcile brightness with mass, activity with density, requires not just sharper instruments but broader imagination. Perhaps 3I divided by Atlas is less a rock and more a relic of another system's chemistry, forged under pressures and temperatures we cannot easily simulate. Perhaps its density profile hides layers of exotic ice or porous scaffolds unknown to our solar system. Each idea is speculative, yes, but each is a door opening toward discovery. By late November 2025, the debate over mass and density had become as heated as any in astrophysics. Teams publish preprints with wildly different conclusions, and yet all agree on one thing: the numbers don't add up. The paradox stands. For the public, it is maddening. For scientists, intoxicating. Because when the universe hands you a puzzle this sharp, it usually means something profound waits on the other side. The deeper scientists dive into 3I divided by Atlas, the more the puzzle seems to multiply. By late November 2025, thousands of measurements have been logged, refined, and compared. Each was supposed to sharpen the portrait. Instead, the face that emerges looks fractured, blurred, sometimes even contradictory. It is like holding a mirror shattered into pieces. Each shard reflects something recognizable, but put them together, and the image makes less sense than before. At the heart of the problem are the limits of our models. Traditional comet science relies on frameworks built from centuries of solar system examples. Those frameworks assume that comets are more or less ellipsoidal, that they vent in predictable patterns, and that dust-to-ice ratios fall within certain bounds. Feed normal data into those models, and the predictions line up. But with 3I divided by Atlas, the models buckle. Plug in the brightness data, and the size estimate shrinks to absurdity. Plug in the coma density, and the mass explodes into the impossible. Tune one side of the equation, and the other collapses. It is like tuning a guitar string that never settles. Tighten it for pitch, and it snaps. Loosen it for flexibility, and it falls silent. Some researchers attempt hybrid models. They picture the nucleus as a patchwork dense slabs alternating with foamy voids, venting unevenly across its surface. Others imagine fractured fragments loosely bound, giving the illusion of a single body. These tweaks help explain certain datasets, but never all. If you match the observed coma brightness, the orbital acceleration fails. If you match the orbital path, the density estimate shatters belief. Each fix is a trade-off. Every adjustment, a reminder that the puzzle has no obvious solution. Scientists describe it as squeezing a balloon. Flatten one bulge, and another swells somewhere else. The limits of observation worsen the tension. From Earth, distance reduces the object to a speck blurred by the atmosphere. Even from Mars, where the geometry is better, instruments were not designed for alien chemistry. The detectors are tuned for Martian dust, not interstellar ices. The data comes in faithfully photons, spectra, brightness curves, but when funneled into human interpretation, they scatter. It is like hearing echoes in a canyon. You know the sound is real, but the reflections confuse direction and distance. Did the voice come from one singer or many? Were the walls close or vast? The echoes won't say, and neither will 3i divided by Atlas. Residuals, those pesky differences between measurement and prediction, become the haunting refrain. In ordinary science, residuals are brushed aside as noise. But here, they cluster. They repeat. They whisper that something systematic is wrong. The comet does not need to explain itself. Our theories need to explain why they keep failing. That realization is both humbling and exhilarating. Humbling because it suggests our frameworks, honed for centuries, are provincial valid for local comets, useless for an interstellar one. Exhilarating because anomalies are history's breadcrumbs, and history gives reminders. Mercury's orbit puzzled Newtonians until Einstein's relativity reframed gravity. Blackbody radiation mocked classical physics until quantum theory rewrote the rules. The discovery of pulsars forced astronomers to accept neutron stars, once thought impossible. Each revolution began with data that shouldn't be there. Now, with 3i divided by Atlas, we are staring at numbers that behave exactly that way, small deviations that refuse to vanish, daring us to invent new physics, or at least new chemistry to account for them. What if, some whisper, the assumptions are wrong at the root? Perhaps 3i divided by Atlas is not a monolithic nucleus but a hollow shell, venting gas through porous cracks. Perhaps its coma interacts with sunlight in ways we have never modeled, scattering photons asymmetrically, making brightness lie about size. Perhaps its ices are exotic, frozen compounds unfamiliar to our labs, venting with dazzling light but little momentum. Each proposal is tentative, fragile, even bizarre. Yet each transforms confusion into opportunity. The mood in the community reflects this paradoxical joy. We are lost, but we are thrilled, one researcher joked at a November symposium. The laughter that followed wasn't dismissive, it was relief. To struggle with models that don't work is exhausting, but also intoxicating. Because deep down, scientists know that every failure to fit the data is not just an obstacle, it is an invitation. The universe is not broken, our expectations are. So they continue, refining, adjusting, proposing. Each new dataset sparks debate, each residual becomes a clue. And though the puzzle grows stranger, the chase grows sweeter. To follow 3i divided by Atlas is to chase shadows in fog shapes shifting, never solidifying, yet always hinting at something profound just out of reach. And that pursuit, as maddening as it is, may be the most valuable gift this paradox has given us. By the final weeks of November 2025, the paradox of 3i divided by Atlas had begun to spill beyond astronomy into philosophy. Scientists may debate coma dynamics and density profiles, but beneath the numbers lies a question more unsettling. What does it mean when nature itself refuses to fit our models? This is no longer just a comet. It is a mirror, and in that mirror we see our own assumptions cracking. Philosophers remind us that science has always advanced through disobedience. The cosmos reveals itself not in agreement but in defiance. When Newton's gravity could not explain Mercury's orbit, it was not Mercury that was wrong. When blackbody radiation broke classical physics, it was not the radiation that erred. Now, 3i divided by Atlas plays the same role. Its contradictions force humility, telling us that our solar system may be too small a classroom for universal rules. We have studied local pupils for centuries, but now a transfer student has arrived, speaking a dialect our textbooks never taught. The implications ripple outward. If comets from other stars can defy our equations, then planetary systems may be far more diverse than imagined. Some worlds may breed fragile snowballs that somehow endure interstellar travel. Others may spawn dense, stubborn bodies that vent without thrust. The diversity itself becomes the lesson. The galaxy is not standardized, not mass-produced. It is handmade, messy, and wildly creative. And 3I divided by Atlas is our first tangible proof. Out of this realization grow new hypotheses. Perhaps interstellar comets are layered with exotic ices, ammonia hydrates, carbon chains, or compounds we have yet to synthesize, producing activity with little recoil. Perhaps they are riddled with cavernous voids, venting spectacularly while their cores remain inert. Perhaps some are even aggregates, clusters of fragments loosely bound, behaving like one object but secretly many. Each hypothesis is tentative, fragile as frost, yet each widens our imagination. And then there is the most daring line of thought. What if the paradox is intentional? Not intentional in the sense of alien engineering, though some whisper that possibility, but intentional as in nature's way of forcing us to grow. A comet that fits every model teaches nothing. A comet that breaks them reshapes science. 3I divided by Atlas may be nothing more than frozen gas and dust, but in its contradictions, it performs the oldest function of the cosmos, to shock us into wonder, to stretch our intellect until it aches. For the public, this paradox becomes a story. Headlines cry out about alien puzzles. Documentaries dramatize the contradictions, and children ask teachers why a comet can vent without moving. And even if the scientific details remain technical, the emotional truth resonates. The universe is stranger than we thought, and that strangeness is beautiful. It is the kind of beauty that unsettles, the kind that keeps you awake at night replaying numbers, the kind that makes scientists grin through frustration because they know they are brushing the edges of discovery. In this way, the paradox of 3I divided by Atlas is not just an obstacle but a gift. It pulls us out of complacency, forces us to question the solidity of our assumptions, and demands that we widen the circle of what counts as possible. To call it a puzzle is accurate. To call it a teacher may be more so. For every contradiction it presents, it points to a gap in our knowledge, a place where humility must meet imagination. And that meeting, awkward and exhilarating, is where revolutions begin. So even as the models groan under the weight of incompatible numbers, even as preprints contradict one another, the mood is not despair but anticipation. The paradox comet has become a symbol, a reminder that the universe is not obligated to be simple, and that our role is not to force it into neat boxes, but to follow where it leads, even into confusion. In confusion, we discover. In paradox, we grow. By the end of November 2025, 3I divided by Atlas has left behind a trail of contradictions as luminous as its emerald glow. Size estimates swing from pebbles to mountains. Coma activity screams of energy, while orbital acceleration whispers of inertia. Density models collapse into extremes, too fragile to survive, too solid to explain. Observations fit in isolation, but never in concert. It is as if the universe laid 5 puzzle pieces on the table, each cut cleanly, but none interlock with the others. The picture remains hidden. Yet in science, to reach this point is not defeat, it is a threshold. The paradox comet has become a map of questions, each pointing toward experiments yet to be done. Already, teams prepare new campaigns. Instruments will measure polarization of light to probe the structure of coma grains. Observatories will refine thermal curves to constrain surface texture. Orbital tracking will continue through December, when 3I divided by Atlas makes its closest approach to Earth's orbit. Each effort is a key, not guaranteed to fit, but essential to try. Because the only way out of a paradox is through. And so, researchers begin to frame testable hypotheses. If outgassing without thrust is real, then the coma should exhibit symmetrical jets measurable in high-resolution spectra. If mass is higher than brightness suggests, then star occultations should reveal a wider shadow than expected. If density is foam-like, then rotational data should show precession consistent with hollow or porous bodies. None of these tests is glamorous, but each is concrete. They transform paradox from frustration into a program, from a riddle into a roadmap. But beyond the labors of science lies something more elusive, the emotional weight of standing before a universe that shrugs at our confusion. There is humility in watching 3I divided by Atlas glide on, indifferent to our struggles. It does not pause to let us measure. It does not clarify its contradictions. It simply exists, silent, while we tie ourselves in knots of theory. And strangely, that indifference makes the pursuit sweeter. The comet owes us nothing. The fact that we can glimpse it at all feels like a privilege. This is where the paradox takes on a kind of beauty. Not the beauty of neat answers, but the beauty of tension, of holding two truths at once. 3I divided by Atlas is small, and it is large. It is fragile, and it is durable. It is active, and it is inert. Each pair cancels, yet each pair teaches. To live with that contradiction is uncomfortable, but it is also human. For isn't life itself full of puzzles that never quite resolve? We are fragile yet resilient, insignificant yet meaningful, bewildered yet searching. Perhaps that is why this comet fascinates beyond science. In its paradox we recognize ourselves. Still, the work continues. December will bring more data, more models, more arguments. Some paradoxes will soften, others sharpen. Maybe the nucleus is truly fragmented, masquerading as one. Maybe exotic ices vent in ways we cannot yet simulate. Maybe the numbers that look impossible now will, in hindsight, become the seeds of a new theory as natural as Newton's or Einstein's once radical ideas. The paradox comet will not yield easily, but it will yield eventually. History assures us of that. For now, the story closes on a note of anticipation. We are left with puzzles unsolved, questions unanswered, and numbers that refuse to play fair. But far from discouraging, it feels like standing at the door of a locked room, key in hand, unsure which lock it fits. The excitement lies not in having solved the riddle, but in knowing the riddle exists, and as 3I divided by Atlas fades slowly into the night sky, it leaves us not with despair, but with the one gift paradox always grants, the certainty that something new waits to be discovered. Picture opening a familiar recipe book and finding every ingredient swapped for something unrecognizable. Sugar labeled as salt, water replaced with vinegar. The kitchen looks the same, the tools are the same, but the flavors that emerge defy expectation. That is what astronomers confronted in late November 2025, as the chemical portrait of 3I divided by Atlas came into focus. It looked like a comet. It glowed like a comet. But its chemistry whispered a language utterly unlike any comet we have catalogued from our own solar system. The headline number, the one that made researchers pause mid-sentence, was the ratio of carbon dioxide to water vapor. For comets born in our backyard, water is king. It dominates every spectrum, every coma, every model. Carbon dioxide is there, yes, but as a minor player, an accent in the orchestra. With 3I divided by Atlas, the orchestra is reversed. Carbon dioxide shouts while water barely hums. 8 parts CO2 for every 1 part H2O. Not an echo, not a variation, but an inversion. The most basic expectation, water as the lifeblood of a comet, is turned upside down. And yet, this is not a miracle, it is not magic, it is chemistry that makes sense once you expand your view beyond the solar system. Perhaps in the nursery where 3I divided by Atlas was born, water ice was scarce, crowded out by carbon dioxide, frozen in layers under alien conditions. Perhaps ultraviolet light from a nearby massive star reshaped its ices, locking water deep while liberating carbon dioxide. Whatever the cause, the lesson is clear. Our solar system's template is not universal. To assume it is would be like traveling to a foreign country and expecting every household to cook with the same spices you grew up with. The strangeness is not evidence of the supernatural, it is evidence of diversity. The feeling this discovery stirred was not fear, but awe sharpened by reason. Imagine standing in your backyard and seeing a tree whose leaves are blue, not green. Your first impulse might be wonder, even disbelief. But if you pause, if you consider the physics of light and pigment, you realize that chlorophyll is not the only path evolution could take. Blue leaves are strange, yes, but not impossible. They expand your understanding without breaking it. 3. I divided by Atlas offers that same lesson. Its chemistry is alien, but it obeys chemistry all the same. And the beauty of it lies in the details. When plotted on graphs, the spectral lines of carbon dioxide leap like mountain peaks, dwarfing the modest humps of water. Astronomers describe the view with a mix of frustration and delight. Frustration, because the models built for water-rich comets simply collapse. Delight, because the collapse means something new. Nature has handed us an example of a comet that expands the very definition of the word. If we had only studied our own, we might have assumed water dominance was law. 3I divided by Atlas proves it is merely local custom. So the hook of part 4 is this. The chemistry of 3I divided by Atlas is both shocking and grounded, both alien and rational. It defies expectation without defying reason. It is not a message from gods, but a message from geology and chemistry played out in a star system we will never see. And in that message lies the thrill, to be shocked without being fooled, to be bewildered without being misled, to feel the floor of assumption shake, and yet know the foundation of science remains unbroken. To grasp how bizarre this chemical portrait is, you have to start with a baseline. In our solar system, comets are essentially frozen time capsules, relics of formation. Their dominant ingredient is water ice. From Halley to 67P, spectra repeat the same song: strong water signatures, modest carbon dioxide, traces of other volatiles like methane, ammonia, or carbon monoxide. The ratios vary, but water always sits at the throne. Even when carbon dioxide peaks, it is rarely more than 1 part for every 2 or 3 parts water. In other words, the cometary recipe of our solar system is water first, with CO2 as seasoning. Now turn the page to 3I divided by Atlas. Here, the recipe is rewritten. 8 parts carbon dioxide for every 1 part water. Imagine walking into a bakery and asking for bread, only to discover the loaves are made mostly of salt instead of flour. The texture still looks familiar, something baked, something crusted, but the taste tells you it belongs to another cuisine entirely. That is what the 8:1 ratio means. Not a minor variation, but a wholesale inversion. The surprise strikes deeper because carbon dioxide and water behave differently under heat. Water sublimates at a higher temperature, carbon dioxide at a lower one. In our comets, as they swing toward the sun, water drives the show. The coma brightens, jets burst, and acceleration is measurable. Carbon dioxide contributes but rarely dominates. With 3I divided by Atlas, the process is flipped. It is venting furiously long before water even plays its part. The green coma we see is not steam from familiar ice, but gas from an alien blend. That inversion is why the paradox of weak acceleration bites so hard. It is powered by the wrong fuel. Scientists try to imagine the nursery where such a recipe could form. Perhaps 3I divided by Atlas, condensed at the frigid edge of another star's disk. In a zone where water ice was rare but carbon dioxide ice was abundant. Perhaps radiation from a nearby star stripped lighter molecules, leaving heavier CO2 behind. Perhaps the chemistry of its parent cloud seeded molecules in proportions we do not see here. Each theory has precedent in laboratory experiments or models, but none has been confirmed. That uncertainty is what excites astronomers. This is not just an anomaly, it is a possibility. Proof that other planetary systems write their comets in other dialects. The analogy most often used is culinary. If you grew up believing bread was always wheat-based, tasting rye bread might shock you. If you discovered bread made of barley, you might raise an eyebrow. But 3I divided by Atlas is like biting into bread made of salt. It challenges not just flavor but definition. Is it still bread if flour is absent? Is 3I divided by Atlas still a comet if water is no longer the lead ingredient? Most scientists say yes, but with a caveat. Our definition of comet just expanded. And that expansion matters, because it teaches us that chemical diversity is not decoration, it is fundamental. If carbon dioxide can dominate here, what else might dominate elsewhere? Ammonia-rich comets, methane-first comets, bodies venting exotic volatiles that our labs cannot yet trap? Each possibility reframes how we imagine the galaxy. The cosmos is not a factory stamping out identical snowballs. It is an artist, experimenting wildly with chemistry. Yet through all this wonder, the mood remains grounded. The data are precise, the spectra undeniable. There is no need to leap into speculation about alien machines or engineered signals. The strangeness has an explanation. It is chemistry, geology, physics playing out under conditions we have yet to study firsthand. That is why scientists describe their mood as astonished but steady. They are not clinging to disbelief, nor drifting into fantasy. They are savoring the delight of the unexpected, while keeping their feet planted in reason. So, the ratio 8:1, CO2 to H2, O is more than a number. It is a reminder that our solar system is not the standard of creation. It is one recipe among many. And 3I divided by Atlas, by inverting the recipe, has already expanded our definition of normal. The true weight of this chemical surprise is not just in the numbers, but in what they imply about origins. Every comet is a fossil, a frozen time capsule from the nursery that birthed it. To find one so dominated by carbon dioxide is like discovering a bone carved in a shape no anatomy book describes. It forces us to rethink not just the object, but the environment that forged it. Planetary scientists emphasize that chemistry is biography. The ices that dominate a comet record the temperature, pressure, and radiation environment of its birth. In our solar system, water rules because the protoplanetary disk where we formed was rich in it, and because the freeze-out line, the point where water vapor condensed into ice, lay within reach of many forming bodies. Carbon dioxide, though abundant, froze farther out and in thinner layers. That is why our comets taste mostly of water, with only a pinch of CO2. But if 3I divided by Atlas carries an inversion, then its birthplace must have been sculpted differently. Perhaps its parent star was hotter, stripping away water vapor. Perhaps ultraviolet light from nearby giants fractured molecules and left carbon dioxide dominant. Whatever the details, its ratios are not random. They are fingerprints of another solar system. The analogy that scientists love is genetic. Just as DNA variations tell us where populations came from, cometary chemistry tells us where bodies were born. Our comets are one dialect, heavy in water, sprinkled with carbon dioxide. 3I divided by Atlas is another dialect entirely. CO2, rich, water poor. By comparing them, we glimpse the galactic equivalent of cultural diversity. It is not that one is right and the other wrong. It is that the galaxy speaks many tongues, and we are only now beginning to hear them. This recognition reframes the way we imagine exoplanetary systems. Until now, much of our understanding came from telescopes, measuring planetary atmospheres, transit depths, and spectral lines from afar. Comets like 3I divided by Atlas offer a different approach. A physical sample, a messenger carrying chemistry directly from another star's nursery. It is as though, instead of reading about a foreign culture in books, someone from that culture walked into our town square, carrying artifacts we could touch and study. The difference is intimate, tangible, and transformative. The paradox, then, is double-edged. On one side, it leaves us baffled why so much CO2, why so little water. On the other hand, it confirms our broader suspicion that our solar system is not the blueprint for all. For decades, exoplanet studies have shown us hot Jupiters, circling stars in days, super-Earths, with no counterpart here. 3I divided by Atlas now joins that chorus, reminding us that even small, icy wanderers are not bound by our rules. The universe is more eclectic, more inventive than our parochial expectations allow. This realization sparks both humility and exhilaration. Humility, because we must admit our models are provincial. Exhilaration, because diversity means more to discover. The galaxy is not a monotone, it is a symphony, with instruments we have not yet named. And 3I divided by Atlas is one note in that symphony, sharp and strange, but undeniably real. So the meaning of the chemical anomaly is larger than chemistry itself. It is a philosophical reminder that nature thrives on variety. Just as languages evolve with accents and idioms, just as cuisines diverge with spices and staples, so too do planetary systems evolve their own recipes for comets. To find one that tastes of carbon dioxide instead of water is not to step into the supernatural. It is to expand the dictionary of what natural means. And that expansion, shocking, bewildering, but rational, is the essence of why 3I divided by Atlas matters. It does not break the laws of science. It stretches them, enriches them, and forces them to grow. And in doing so, it reminds us that every anomaly is not a threat to understanding, but an invitation to deepen it. If the chemistry of 3I divided by Atlas startled scientists, its orbit left them speechless. For centuries, every comet and asteroid we have studied has traced some kind of closed curve around the sun ellipses of varying size, sometimes stretched, sometimes nearly circular, but always bound. Even long-period comets, drifting for millions of years from the Oort cloud, remain tethered. They leave, but they return. Their paths are invitations to patience. Wait long enough, and the traveler will swing back again. But 3I divided by Atlas carries no such promise. Its trajectory is hyperbolic, a curve that declares finality. It is not orbiting. It is passing through. To picture a hyperbola, imagine a marble in a bowl, push it gently, and it rolls up the side, slows, and slides back an ellipse in miniature. Push harder, and it reaches the rim, pauses, and falls back still bound, still belonging. But strike it with enough force, and it flies clear over the rim, never to return. That is the essence of hyperbolic motion. The sun is the bowl, the planets are spectators. 3I divided by Atlas is the marble, hurled with such velocity that the bowl cannot hold it. It came from elsewhere, and it is destined for elsewhere. We catch it only in passing, like a stranger glimpsed once in a crowd before disappearing forever. The mathematics underlie the drama. A bound orbit has eccentricity less than 1. A perfect parabola, the dividing line between capture and escape, has eccentricity exactly 1. 3I divided by Atlas exceeds that threshold. Its eccentricity is not just a hair above unity, it is decisively hyperbolic. No gravitational trick, no hidden planet, no gentle braking will turn its path into an ellipse. It is free, irreversibly. That single number transforms it from visitor into exile, an object forever homeless in our sky, and this realization strikes at our sense of cosmic permanence. So much of astronomy is cyclical: the moon phases, the Earth's orbit, the return of comets across centuries. To meet something that does not return feels unsettling, almost emotional. It is like saying goodbye to someone you have only just met, knowing you will never see them again. That finality sharpens the awe. We are not just watching a celestial show, we are attending a farewell performance. Yet even here, the strangeness is not supernatural. Hyperbolic orbits are the natural outcome of interstellar wanderers. Give an object enough velocity, perhaps from a stellar nursery collapse, perhaps from a planetary collision, and it will drift between stars. Physics predicts it, telescopes confirm it. The wonder lies not in magic, but in mathematics. What feels miraculous is simply the rare chance that such an object's path crosses ours, at the right moment, in the right century, for our species to notice. The implications ripple outward. If 3I divided by Atlas can pass through, so can others. Perhaps the galaxy is filled with such wanderers, fragments exchanged between stars like cosmic postcards. We have simply not noticed until recently, because our instruments were blind. Now, with sharper eyes, we see what was always there. The galaxy is not a set of isolated systems, but a web of travelers, messengers bearing the chemical stories of their homes. So when scientists trace the hyperbola of 3I divided by Atlas, they do more than plot points on a chart. They mark the path of an emissary, an exile whose presence is fleeting but meaningful. Its orbit is a line drawn through our solar system, pointing backward to origins we cannot see, and forward to destinations we will never follow. It is geometry, yes, but it is also poetry, and in that poetry lies the awe, strange, but never beyond reason. By the close of November 2025, the portrait of 3I divided by Atlas is not neat, but it is unforgettable. Its chemistry screams of carbon dioxide, flipping the recipe we assumed was universal. Its orbit sketches a hyperbola, promising never to return. Together, these traits forge an image that feels almost mythical, a body both alien and ordinary, both baffling and natural. It shocks us, yes, but it shocks us in ways that deepen science rather than break it. The temptation, of course, is to read the strangeness as supernatural. For centuries, every anomaly in the sky carried whispers of omens, portents, divine messages. A comet that glows green and flees forever might once have sent cities into panic. But today, we hold to a different posture, astonishment anchored in evidence. We marvel, but we do not abandon reason. The anomaly is strange, not miraculous. It belongs to physics, not prophecy. That distinction is what makes the experience powerful. We are free to feel wonder without fear, to feel awe without superstition, and that awe is sharpened by its impermanence. 3I divided by Atlas will not loop back in a century to greet our grandchildren. It will not become a familiar entry in cometary catalogues. It will fade, and it will be gone, and we will be left only with data. But perhaps that is the gift. Knowing this encounter as singular forces us to value it more. It is like hearing a song played only once in your lifetime. The melody burns deeper because it cannot be repeated. Our instruments record, our graphs preserve, but the experience itself belongs only to this generation. The chemistry and the orbit together tell a consistent story. The universe is richer, stranger, and more varied than our backyard ever suggested. Carbon dioxide dominance shows us that planetary nurseries write different recipes. A hyperbolic path shows us that stars trade debris like seeds scattered by the wind. The message is not mystical but ecological. We live in a galaxy that is messy, diverse, and alive with exchange. We are not isolated. We are part of a dynamic web. And so, Part 4 closes with a paradox of its own. We are left both satisfied and unsatisfied. Satisfied because the anomalies chemical and orbital fit into natural frameworks, however stretched. Unsatisfied because those frameworks are not enough. They explain the how, but not fully the why. Why this ratio, this path, this timing? Why here? Why now? These questions hover, unanswered, but they do not diminish the discovery. They amplify it. The more we ask, the more valuable the data becomes. 3. I divided by Atlas, then, is not a ghost or a miracle. It is a messenger. It carries in its chemistry the fingerprints of another system, and in its trajectory the map of a journey across interstellar space. It is strange, yes, but not beyond reason. It is alien, yes, but not beyond nature. And in that balance lies the wonder. We are astonished, we are bewildered, and yet we remain grounded. This is what it means to encounter the unknown as scientists, as thinkers, as a species reaching out of its cradle. As December approaches and the comet speeds toward perihelion, attention shifts from what we have already learned to what comes next. More data will pour in, more contradictions will surface, and the puzzle will grow. But for now, we can pause. We can stand in the presence of a chemistry that rewrote our expectations and an orbit that reminded us of impermanence. We can feel awe that is sharp, reasoned, and real. Strange, yes. Supernatural, no. When news first broke that 3I divided by Atlas was passing through our solar system, the public expected answers overnight. It is easy to imagine science as instant. A telescope opens, a shutter clicks, and truth appears on the screen like a news headline. But science is not a headline. It is a journey. Every photon from 3I divided by Atlas must travel not only millions of miles through space, but also weeks of processing through human minds and machines before it becomes knowledge. What we call delay is not negligence. It is the cost of transforming raw light into reliable truth. The journey begins at the moment of capture. A photon departs from the comet's glowing coma, crosses interplanetary voids, and finally lands on the cold surface of a detector. That moment feels miraculous. Yet what the detector records is not an image, not even data we can recognize, but voltage, tiny electric disturbances buried in noise. To scientists, it looks like static on a broken television. The first step is translation, converting those voltages into numbers representing brightness, wavelength, and position. But translation is never perfect. Cosmic rays leave scratches across the digital canvas. Dust inside the optics mimics phantom stars. Detectors themselves hiccup, producing false blips. Before any story can be told, the static must be separated from the signal. This cleaning stage is meticulous. Algorithms subtract background stars, normalize exposure times, and align the frames. Each adjustment risks creating illusions if done carelessly. So, scientists check and cross-check, documenting every line of code, every calibration. They treat data the way a forensic team treats evidence, carefully bagged, labeled, verified. The goal is not speed but integrity. A wrong assumption here could ripple outward, turning a smudge into a false discovery. Once cleaned, the data enters analysis. Now patterns begin to emerge. Spectral lines hint at chemistry. Light curves reveal spin. Faint occultations sketch the nucleus's size. But these patterns are fragile. A spike in one dataset could be an artifact, not a revelation. To separate anomaly from error, researchers compare across instruments. Does the same carbon dioxide line appear in multiple telescopes? Does the same dip in brightness occur from different viewing angles? Redundancy is the shield against self-deception. Each match strengthens confidence. Each mismatch forces humility. Analysis is followed by review. Draft findings circulate within teams. Every claim is interrogated. Could it be dust? Could it be a software bug? Could it be a coincidence? The tone is not hostile but protective, as guardians of truth. Scientists know the stakes. Once released, a result shapes headlines, classrooms, and even funding. Better to catch errors inside than let the world build its imagination on quicksand. That is why drafts can spend weeks bouncing back and forth, revised again and again. To outsiders, it looks like a delay. To insiders, it looks like quality control. And only then, when internal storms of doubt quiet, does knowledge trickle outward. First, at conferences, where colleagues prod it. Then to journals, where reviewers dissect methods. Only after that does it reach the public as discovery. By then, what emerges is not raw data, but tempered fact, hammered on the anvil of skepticism. This is why the timeline feels slow. Headlines chase hours. Science takes weeks. Headlines thrive on immediacy. Science thrives on endurance. Rumor is quick but brittle. Truth is slow but unbreakable. The waiting is not wasted time. It is the very process that makes knowledge trustworthy. So when the public wonders, why don't we know yet? Why hasn't the mystery been solved? The answer is not silence. The answer is, because truth deserves patience. Every extra day is another test run, another safeguard. Every pause is an investment in certainty. The discipline of delay is itself proof that science is working. This is the hook of part 5. The very slowness that frustrates is the reason you can trust what finally arrives. 3. I divided by Atlas may be fleeting, its visit brief, but the truth it leaves behind will be solid, precisely because we waited, precisely because the pipeline of science demands rigor before revelation. To understand why science takes time, it helps to compare it with processes closer to home. Imagine brewing beer. You cannot rush fermentation. You can add yeast, you can warm the room, but if you bottle too soon, the flavor collapses. Or think of making sourdough bread. The starter needs days to bubble, to balance bacteria and yeast. Try to cut corners, and what comes out of the oven is not bread, but disappointment. Science is the same. The flavor of knowledge depends on letting the process unfold fully. Medical testing offers another parallel. When you go to a hospital for blood work, you don't expect results in 10 minutes. The sample must be spun, separated, tested, cross-checked, and often sent to another lab. Each step reduces the risk of false positives or false negatives. Would you trust a doctor who gave you a life-altering diagnosis based on one glance at a single slide? Of course not. You trust the waiting, even if it is hard, because you know the waiting means accuracy. In the same way, astronomers resist the pressure to publish after the first look. They want to make sure the diagnosis of 3I divided by Atlas is right, not just exciting. The justice system provides another analogy. In a courtroom, evidence passes through chains of custody. Police bag it, labs test it, lawyers challenge it, judges rule on it. No single step guarantees truth, but the combination builds confidence. If a shortcut breaks the chain, the entire case collapses. Data about 3I divided by Atlas moves through a similar chain. Sensors record, algorithms clean, scientists analyze, reviewers critique, break any link, and the conclusion is tainted. The patience to preserve the chain is not bureaucracy, it is protection. Even food safety tells the same story. In the United States, meat passes through inspections, certifications, and quality checks before reaching a grocery store shelf. No one sees those steps, but everyone relies on them. Without them, dinner could be dangerous. Likewise, the invisible steps of astronomy, calibrating detectors, subtracting noise, confirming spectra, may not make headlines, but they are why the headlines can be trusted when they finally appear. These analogies are not just rhetorical tricks, they reveal something essential about the rhythm of human trust. We instinctively value products and results that have been tested, refined, and aged. A vintage wine carries prestige not because it was bottled quickly, but because it was given years to become what it could be. Scientific truth is vintage knowledge. It earns weight through time, through the refusal to be rushed. This is why scientists push back gently when the public grows restless. They understand the hunger for answers, especially with an object as strange as 3I divided by Atlas. But they also know that rushing could backfire. A premature claim, later retracted, would not only damage credibility, but also fuel conspiracy theories. Far better to wait and deliver something solid. The wait is the warranty. So the message to the public is this: Treat the delay not as a void, but as reassurance. The fact that you do not yet know the final truth means the system is working. It means multiple teams are checking one another. It means every step is logged, debated, and tested. The quiet is not neglect, it is diligence. The silence is not emptiness, it is incubation. When you next see a headline that feels slow in coming, remember the beer that needed to ferment, the bread that needed to rise, the case that needed to be tried. Quick news is fast food, satisfying in the moment, but rarely nourishing. Science is a home-cooked meal. It takes longer, but when it arrives, it sustains. The urge to announce quickly is powerful. In a media culture that thrives on immediacy, being first often feels like being right. But in science, being first without being correct is worse than being late. A premature claim can ripple for years, eroding trust not just in one project but in the entire community. That is why astronomers are deliberately cautious with 3I divided by Atlas. They know the cost of haste. History offers reminders. Decades ago, a signal called the Martian Canals was trumpeted as proof of civilization on Mars. Telescopes were smaller, data less precise, but the excitement was irresistible. Later, better optics revealed they were illusions, tricks of light and human imagination. The backlash was not just disappointment, it scarred public trust for generations. More recently, announcements of potential biosignatures in Venus's atmosphere, hints of phosphine were splashed across headlines, only to be questioned, revised, and largely withdrawn. Each premature claim became fuel for skepticism. If they were wrong then, why trust them now? Scientists have not forgotten. The analogy is simple. Imagine publishing a book full of typos because you rushed to print. Readers might forgive one mistake, but dozens erode credibility. Worse, the next time you release a book, people hesitate to buy it. Science works the same way. Credibility is cumulative. Guarding it requires restraint. That is why data about 3I divided by Atlas moves slowly. Not because scientists are lazy, but because they are careful editors of nature's manuscript. The risks of speed are not just reputational, they are practical. If early claims set expectations too high, funding priorities may shift, resources may be wasted, and young researchers may chase mirages instead of solid leads. Imagine steering a ship based on a faulty compass. The further you sail, the more lost you become. One wrong press release can misdirect entire fleets of research. Scientists prefer the delay of recalibration over the chaos of correction. And so, the information gap that frustrates the public actually protects them. By refusing to fill silence with speculation, scientists shield society from cycles of hype and disillusionment. They transform impatience into durability. The fact that you must wait weeks for firm conclusions about 3I divided by Atlas means those conclusions, when they arrive, will be tested, weighed, and strong enough to survive scrutiny. Delay becomes armor. Even within teams, caution reigns. Imagine a driver speeding on an icy road. They may get home faster, but the risk of crashing outweighs the minutes saved. Astronomers feel the same way as they process comet data. They could rush to announce a headline tomorrow, but if it collapses under peer review, the damage would echo longer than the thrill of being first. Better to drive slow and steady, arriving late but safe. This is why the scientific community insists that delay is not weakness but strength. It is a discipline that protects against error and ensures that when a discovery enters textbooks, it stays there. Nobody wants 3I divided by Atlas to be remembered as another footnote in the history of mistakes. They want it to endure as a case study of discovery done right. Astonishing, yes, but also reliable. So the public must reframe impatience. The pause is not emptiness, it is protection. The silence is not secrecy, it is rigor. If knowledge is a bridge, each day of waiting is another beam laid, another joint secured. Walk across too soon, and the span may collapse. Wait, and the bridge will hold not just for you, but for generations after. The story of 3I divided by Atlas is strange, even unsettling. But the way we process that story, the careful pace, the deliberate silence, is what makes it trustworthy. In a world of instant feeds and viral speculation, science's refusal to rush is not a flaw. It is its greatest strength. By the end of November 2025, the patience of the public had begun to fray. People want answers. They want certainty about what 3I divided by Atlas is, where it came from, and what its strange chemistry and orbit mean. Instead, they receive silence punctuated by cautious statements. To some, that silence feels disappointing, even suspicious. But to scientists, the silence is sacred. It is the sound of care. It is the proof that the pursuit of truth is not rushed by the tempo of social media, but guided by the slower rhythm of reliability. Think of a great oak tree. It does not sprout to its full height in a single season. It grows rings year after year, layer upon layer, until its trunk is strong enough to weather storms. Knowledge is the same. Each layer of data, each cycle of review, adds strength. If you try to speed its growth, you do not get a mighty oak, you get a brittle stalk that snaps in the first wind. The slowness of science is not weakness, it is durability made visible. This perspective changes how we interpret delay. It is not empty time, it is active time. Time in which teams compare notes, rerun calibrations, hunt for hidden biases. It is time in which skepticism is allowed to do its work, burning away errors until only durable truth remains. To demand immediacy is to ask for raw ore instead of refined metal. It glitters less, but it endures more. And here is where trust is built. In an era of misinformation, where rumors race faster than facts, the very slowness of science becomes its defense. You can tell the difference between spectacle and science by watching how fast the story moves. Spectacle shouts today and fades tomorrow. Science whispers for weeks and then stays for decades. When we look back on 3i divided by Atlas, we will not remember the impatience of waiting. We will remember the solidity of what eventually emerged. The process itself can be a source of pride. To know that humanity is willing to wait, to insist on rigor even when the world demands speed, is to recognize our maturity as a species. Children want candy now. Adults understand that a harvest takes seasons. In the same way, our response to 3i divided by Atlas reveals whether we act as impatient consumers of wonder or as guardians of truth. Choosing patience is itself a victory. This is not to say the waiting is easy. R sharpens hunger. The comet dazzles with its emerald glow, its hyperbolic escape, its chemical strangeness. We long to know now, but here, patience becomes part of the story. When the truth finally arrives, it will carry the flavor of the wait. Just as a long-aged wine tastes richer for its years in the barrel, the knowledge of 3i divided by Atlas will be sweeter for the silence that preceded it. So Part 5 closes not with frustration, but with reassurance. The pipeline is long, the delay real, but both are necessary. They are not obstacles to discovery, they are the architecture of discovery. To be asked to wait is to be invited into the discipline of science, to share in the humility and caution that make it trustworthy. As December begins, and new data from 3i, divided by Atlas, trickles slowly into consensus, we can see the pause for what it is, not a void, but a virtue. We are not watching science stumble, we are watching it stand tall, even against the pressure of impatience. And in that stance lies something worth celebrating, the reminder that truth, like an oak, grows slowly, but when it stands for centuries. Picture the internet as a vast room filled with voices, some speaking facts, others whispering rumors. Now imagine someone drops the name 3i divided by Atlas into that room. Almost instantly, a web begins to form. Threads of speculation shoot out in every direction. Secret weapons, alien probes, cosmic omens. Each thread catches a reader. Each reader adds another strand. And before long, a sticky net of conspiracy has grown large enough to snare millions. This is the danger we face, not the comet itself, but the stories told about it. The hook here is simple but urgent. When the real data takes weeks to process, hype fills the gap in hours. Conspiracies thrive in silence. They offer quick answers when science insists on slow ones. And so, in late November 2025, as 3i divided by Atlas continues its strange journey past Mars and toward the Sun, the loudest narratives online are often the least reliable. The irony is cruel. While scientists quietly work through terabytes of photons, social feeds erupt with viral threads claiming certainty. The patient work of truth is drowned out by the seductive noise of speculation. Why do conspiracies form so fast? Because they are easier. They do not need calibration curves, error margins, or peer review. They only need a hook strong enough to spark curiosity and fear. A green glow in the sky becomes evidence of alien engines. A hyperbolic orbit becomes proof of an object fleeing after spying on us. The lack of acceleration becomes deliberate control. Each claim ignores physics, but each spreads anyway, because in the attention economy, emotional impact beats factual accuracy every time. This is where evidence literacy matters. We cannot stop rumors from forming, but we can stop ourselves from becoming entangled. Just as hikers learn to spot poisonous plants, citizens of the information age must learn to spot poisonous claims. Ask, where did this claim originate? What evidence is shown? And is it primary or second-hand? Does the explanation align with known physics, or does it contradict without offering proof? These questions act like scissors, cutting through the sticky threads of the conspiracy web. But the fight is not only external, it is internal. Conspiracies prey on psychological instincts. They flatter us by offering secret knowledge, you know what the experts won't admit. They feed our craving for narrative, turning random anomalies into plots. They exploit distrust, whispering that institutions hide the truth. All of this makes them magnetic, especially when real answers are slow to arrive. Recognizing this helps us resist not just the claims but the emotions they manipulate. In this sense, 3i divided by Atlas has become more than a comet. It has become a test of evidence literacy, a mirror showing how we handle uncertainty. Do we fill the silence with imagination, or do we wait for data to ripen? Do we let threads of rumor bind us, or do we cut through them with reason? The comet itself does not care. It glides on, indifferent. The choice is ours, and that choice begins with vigilance. Not paranoia, not cynicism, but rational caution. A mindset that says, extraordinary claims require extraordinary evidence. That mindset does not kill wonder, it protects it. By refusing to be captured by the conspiracy web, we keep our awe focused where it belongs, not on human rumors, but on the strange, beautiful reality of an interstellar visitor racing through our sky. Why are human beings so vulnerable to hype and conspiracies? The answer lies not in stupidity but in psychology. Our brains are wired to prefer quick stories over slow uncertainty, patterns over randomness, drama over nuance. In evolutionary terms, these instincts once kept us alive. Spotting a false pattern in the grass, mistaking wind for a predator, was safer than missing the real predator when it appeared. Suspicion was survival. Today, those same instincts make us fertile ground for conspiracy. Cognitive science calls this pattern-seeking bias. Faced with unexplained events, we invent causes rather than accept gaps. A comet with a strange green glow? Surely. A machine? An orbit that doesn't return? Surely a mission, not a rock. Our discomfort with, I don't know yet, pushes us toward, I know, even if it's wrong. And in the age of social media, where every rumor has a microphone, these instincts no longer whisper, they roar. Another factor is confirmation bias. People seek evidence that supports what they already fear or hope. If you distrust institutions, every scientific delay looks like a cover-up. If you believe in alien life, every anomaly looks like contact. This bias doesn't just color interpretation, it controls attention. You scroll past thousands of ordinary data points, but stop and share the one headline that fits your worldview. Thus, conspiracies spread, not because the evidence is strong, but because the psychology is strong. Emotions add fuel, fear sharpens memory, surprise makes stories sticky, outrage drives sharing. A claim that 3i divided by Atlas is just another comet might be accurate but feels dull, while 3i divided by Atlas is an alien craft fleeing the sun sparks adrenaline. Our brains reward novelty, not accuracy. Studies show false news spreads faster than truth online precisely because it is crafted for emotional punch. What frightens or excites us jumps from mind to mind more easily than what merely informs us. Social dynamics magnify the pull. Believing in a conspiracy can create a sense of belonging. Online groups form around shared secret knowledge, offering community to those who feel excluded from mainstream authority. To doubt, the official line becomes a badge of independence. In this way, the conspiracy is not just about 3i divided by Atlas, it is about identity. To reject hype is to risk loneliness. To accept it is to join a tribe. That social glue is powerful, especially in uncertain times. All of this explains why hype races ahead of evidence. It is not that people want to be wrong, it is that people want to feel certain, feel special, feel connected. Conspiracies provide those feelings instantly. Science cannot. Science insists on patience, on error bars, on not yet. And so the psychological scales tilt toward rumor unless we deliberately push back. The tragedy is that these same mechanisms distort awe. The true wonder of 3i divided by Atlas lies in its chemistry, its orbit, and its very existence as an interstellar visitor. But hype hijacks that awe, bending it toward fear or fantasy. Instead of marveling at nature's diversity, people end up frightened by shadows of alien fleets or hidden agendas. The awe is real, but misdirected. Recognizing the psychology helps us reclaim it. When we feel the tug of a dramatic story, we can pause and ask, am I reacting to evidence or to emotion? When we notice ourselves drawn to a group that claims insider knowledge, we can ask, does belonging require abandoning reason? Awareness is not a cure, but it is armor. Knowing our instincts prepares us to resist them, and this is where evidence literacy merges with emotional literacy. To guard against conspiracy, we must not only check facts but also check feelings. We must learn to recognize that thrill of knowing a secret for what it is, a neural trick, not a revelation. Only then can we stay anchored, refusing to let hype rewrite our wonder. So as 3i divided by Atlas glides on, surrounded by a haze of rumors, the real test is not just scientific, it is psychological. Can we admire without exaggerating? Can we wait without filling the silence with fantasy? The comet will not decide that for us. We must decide it for ourselves. So how do we guard ourselves against the conspiracy web? Awareness of psychology is the first step, but action requires tools. That is where a practical checklist becomes powerful. Just as pilots run through pre-flight routines before takeoff, evidence-literate citizens can run through questions before sharing or believing a claim. Think of it as your anti-hype survival kit, especially in moments like November 2025, when 3i divided by Atlas sparks both fascination and misinformation. Step 1. Check the source. Where did this claim originate? Was it a peer-reviewed journal, an official observatory release, or an anonymous thread on social media? Reliable science always leaves a paper trail. Conspiracies often hide behind vague phrases like "they say" or "insiders revealed." If the origin is murky, so is the claim. Step 2. Ask for evidence. Is there actual data spectra, orbital measurements, images that support the claim? And more importantly, is that data verifiable by independent observers? In astronomy, multiple telescopes around the world can often confirm the same feature. If only one blurry image circulates without coordinates or calibration, caution is warranted. Extraordinary claims demand extraordinary evidence, not recycled memes. Step 3. Cross-check with known physics. Does the explanation align with what we know about gravity, chemistry, or orbital dynamics? A claim that 3i divided by Atlas, slowed down deliberately, ignores basic mechanics. No object can break in a vacuum without thrust. A claim that its green glow proves alien technology forgets that carbon molecules emit green when excited. If a story demands you throw away centuries of tested science, be skeptical. Step 4. Watch the language. Science speaks in cautious terms. Preliminary, uncertain, further study needed. Conspiracies speak in absolutes. Proof, undeniable. They don't want you to know. The tone is a clue. Trust the voice that admits uncertainty over the one that claims certainty without evidence. Step 5. Follow the timeline. Real science takes weeks or months to emerge. If a story claims to have solved the entire mystery of 3i divided by Atlas overnight, ask yourself, did they bypass the data pipeline we discussed earlier? Impatience is often a red flag. Truth is slow, hype is fast. Step 6. Ask who benefits. Does spreading this claim serve curiosity, or does it serve clicks, fear, or profit? A YouTube video shouting, "Alien invasion confirmed," may be chasing ad revenue, not truth. A scientific press release gains nothing by delaying, except accuracy. Motive matters. Step 7. Compare multiple sources. A claim worth believing will appear in more than one credible outlet. If only fringe sites echo it, while mainstream science remains cautious, the imbalance speaks volumes. In evidence literacy, silence from experts is not a conspiracy, it is rigor. These steps are simple, but together they act like armor. They do not make you invincible, but they give you pause, and pause is power. The speed of hype relies on reflex, see, feel, share. The discipline of truth relies on reflection, see, think, then decide. The checklist is how you slow the reflex long enough to let reason in. Consider how this plays out with 3i divided by Atlas. A viral tweet says, "It's slowing down, it must be controlled." Step 1. Source, an anonymous handle. Step 2. Evidence, none. Step 3. Physics. Objects don't break without thrust. Already, the claim collapses. Another post claims, "Its green glow is alien energy." Source, a blog. Evidence, a photo without calibration. Physics. Carbon molecules explain the glow. Again, the checklist cuts the thread of conspiracy before it binds. The point is not to kill imagination, but to ground it. Wonder survives even when rumors are debunked. In fact, wonder is sharper when it rests on truth. Evidence literacy does not dampen awe, it preserves it from distortion. With tools like this checklist, we can protect our fascination with 3i divided by Atlas from being hijacked by fear or fantasy. In an age when information spreads faster than comets, skepticism is not cynicism, it is citizenship. To demand evidence is not to reject wonder, but to defend it. And that is how we keep the conspiracy web from catching us thread by thread, with scissors of reason in hand. Conspiracies spread like sparks, but evidence is built like stone. One burns bright and fast, the other stands for centuries. This contrast is crucial in the story of 3i divided by Atlas. While social feeds erupt with instant explanations, scientists are still sifting, testing, calibrating. To some, the slowness looks like weakness. In truth, the slowness is strength, because evidence is not a headline, it is infrastructure, and infrastructure is meant to last. Think of a courtroom. Hype is like gossip shouted in the hallway. Evidence is testimony admitted under oath. No verdict is based on rumors, only on facts tested, challenged, and confirmed. Science is humanity's courtroom. Data is sworn testimony. Peer review is cross-examination. The verdict may take time, but when it comes, it carries authority. You would not want a jury to decide your fate on a rumor. Why would we decide the fate of the truth about 3i divided by Atlas any differently? Or picture a bridge. Hype is scaffolding thrown together overnight, impressive but unstable. Evidence is concrete poured slowly, cured carefully, and tested under load. It takes longer, yes, but when you step onto it, it holds. Scientific claims are bridges between ignorance and understanding. If we demand that they be built overnight, we should not be surprised when they collapse under the weight of scrutiny. If we wait, we inherit structures that endure. Agriculture offers another analogy. A tree grown in haste is shallow-rooted, vulnerable to storms. A tree grown with time lays roots deep, spreads branches wide, and offers shade for generations. Evidence is that deep-rooted tree. Its fruit may not ripen overnight, but once it does, it nourishes far longer than the fast, sugary thrill of rumor. This is why scientists are unapologetic about the delay. They know the public wants answers now, but they also know answers given too soon will not survive. Each calibration, each replication, each cautious phrase, preliminary, tentative, uncertain, is not weakness but honesty. It is the language of humility in the face of nature. And humility, though less flashy than certainty, is what builds trust over decades. The case of 3i divided by Atlas makes this point vividly. Already, hype has declared it alien, artificial, conspiratorial. Yet none of those claims show their work. None provides raw data, methods, or peer review. In contrast, scientific teams move slowly but leave a paper trail anyone can check. Their findings may change, refined, sharpened, corrected, but they do not vanish. They grow sturdier with each iteration. That is what separates evidence from speculation. One evaporates under pressure, the other crystallizes. And evidence has another strength. It scales. A rumor may convince a circle of believers, but evidence convinces across nations, cultures, and time. Equations hold whether whispered in English, Mandarin, or Spanish. Spectra of carbon dioxide look the same in Tokyo or Tucson. Truth, once tested, transcends tribe. That universality is why evidence matters more than ever in an age of fragmented media. It gives us something we can share even when we disagree on almost everything else. So the lesson is clear. Hype thrills, but evidence endures. If you want the rush of adrenaline, conspiracies will always deliver. But if you want the steady ground to stand on, only evidence provides it. The wait may feel long, the language may sound cautious, but the reward is knowledge that does not collapse when tomorrow's rumor blows through. And this, ultimately, is what protects wonder. Because awe rooted in hype fades when the claim is disproven, but awe rooted in evidence deepens. When the chemistry of 3i divided by Atlas is confirmed, when its orbit is nailed down, when its mysteries are resolved step by step, the wonder will be richer precisely because it is real. We will not have to apologize for being fooled. We will be able to marvel without regret. In the end, the real challenge of 3i divided by Atlas is not only scientific, it is cultural. The comet tests not just our instruments but our instincts. It asks whether we will let ourselves be captured by the rush of rumor, or whether we will cultivate a discipline of patience and clarity. This discipline has a name: the anti-hype mindset. What does it mean to live with such a mindset? It begins with humility. The willingness to say, "I don't know yet," is not weakness, it is wisdom. In a culture addicted to instant takes, the courage to hold silence until evidence arrives is revolutionary. Anti-hype is not cynicism, it is measured optimism. It says, "I will wait, not because I lack curiosity, but because I value truth enough to let it ripen." Second, it requires practice. Evidence, literacy, like fitness, is built through repetition. Each time you stop before sharing a sensational post, each time you run through the checklist: source, evidence, physics, language, you strengthen the muscle of discernment. Over time, restraint becomes reflex. What once felt like effort becomes habit. Just as athletes train their bodies, citizens of the digital age must train their skepticism. Third, it expands beyond astronomy. The same tools that cut through conspiracies about 3i divided by Atlas protect us in other arenas: health, finance, politics. A miracle cure trending on social media, a guaranteed investment scheme, a viral claim about election fraud, all follow the same logic as comet conspiracies. They thrive on speed, emotion, and tribal identity. The anti-hype mindset, once built, becomes armor everywhere. Fourth, it builds community. Skepticism is often painted as lonely, but it can be collective. Families can adopt habits of checking sources together. Classrooms can teach evidence literacy as a civic skill. Online groups can celebrate patience instead of clicks. Imagine a culture where restraint is admired, where "I'll wait for the data" is seen not as boring but as brave. That culture would be harder for conspiracies to colonize. Finally, it protects wonder. This is the paradox worth holding on to. Anti-hype does not reduce awe, it enriches it. When the truth about 3i divided by Atlas emerges, not the rushed fantasy, but the tested fact, we will marvel more deeply because our awe will not be mixed with regret. We will not have to unlearn headlines or swallow disappointment. We will be able to say, "We waited, we doubted, and now we know." That knowledge, earned through patience, will be sweeter than any viral thrill. So as 3i divided by Atlas streaks across the sky, surrounded by webs of rumor and speculation, let us choose differently. Let us cut through the sticky threads, hold to evidence, and practice the discipline of delay. Let us model the anti-hype mindset not just for ourselves, but for the generations who will inherit both the comet's legacy and the information systems we leave behind. Because in the end, the true legacy of 3i divided by Atlas may not be its chemistry or its orbit, but the way it taught us to navigate uncertainty. It reminded us that awe and skepticism can coexist, that patience is not weakness, and that truth worth having is truth worth waiting for. In that sense, the comet has already given us a gift, not just data, but discipline. Imagine sitting in front of a chessboard where the opponent is the universe itself. The board is set, the pieces are placed, but the rules say no move can be made unless the same position is confirmed twice. That is the situation facing astronomers in early December 2025. The comet 3i divided by Atlas has revealed flashes of data, hints of anomaly, sparks of possibility, but not yet the repeatable confirmations that transform rumor into fact. And so, instead of crowning one narrative, scientists sketch scenarios, conditional outcomes that will only stand if the evidence repeats under scrutiny. At present, 3 broad scenarios dominate the discussion. The first is the most cautious. 3i divided by Atlas is a natural comet, unusual only in its chemistry and orbit, but still explainable within the elastic boundaries of known science. It may bend our expectations, but it does not break them. The second is more demanding. The comet is natural, but its peculiarities are so persistent that they force us to expand or revise models of cometary formation and interstellar chemistry. In this view, 3I divided by Atlas would be a messenger from environments unlike any we have modeled, compelling us to add new chapters to planetary science. The third scenario is the least probable but most sensational, that some signals, such as recurring reflective glints or unaccounted for trajectories, might hint at an artificial origin. Scientists emphasize its improbability, but they do not erase it entirely, for science's duty is to test, not to assume. What keeps all three scenarios alive is a single word: reproducibility. In science, one anomalous measurement does not carry authority. One spectral line, one curious curve, one flash of light can always be an artifact, a sensor glitch, a reflection from a satellite, even a mote of dust on a lens. The line between discovery and noise is crossed only when results repeat, across instruments, across nights, across teams. A glint that appears once is intrigue. A glint that appears twice, in the same geometry, becomes a possibility. A glint that appears 3 times, measured independently, becomes evidence. This ladder of confidence is what conspiracy theorists ignore and what scientists insist upon. This is why the narrative feels slow. In an online world, conclusions form overnight. It's just a rock. It's a probe. It's being covered up. In labs and observatories, the mood is different. Quiet, cautious, disciplined. Scientists do not yet have verdicts. They have hypotheses conditional on evidence that has not yet been repeated. They speak in terms like if, pending, and to be confirmed, not because they are timid, but because they are honest. Honesty in science does not sound like certainty. It sounds like patience. The hook for part 7 is this: uncertainty is not a void. It is architecture. Scenario mapping is not idle speculation. It is structured imagination. It is the way science honors the unknown without pretending to fill it with premature certainty. To say, here are the 3 main possibilities, here is what would support each, here is how we would know, is not weakness, it is discipline. And that discipline is the best defense against hype. So, as December begins, the story of 3I divided by Atlas is not about closure, but about frameworks. If reflective glints repeat at specific geometries, then one scenario gains ground. If spectra confirm exotic ices across multiple instruments, then another rises. If neither repeats, then the simplest explanation, the natural comet, remains strongest. The comet's mystery will not be solved in one leap. It will advance step by step, built on evidence that proves itself not once but many times. And here is the invitation to the public, to share the scientist's posture of cautious patience. 3. I divided by Atlas is fleeting, but the truth about it must endure. That endurance can only be earned through reproducibility. The board is set, the pieces are in place, but the cosmos has not yet shown its hand. The wisest move is to wait, watch, and let the next pattern emerge. The first scenario on the scientist's board is also the most likely. 3I divided by Atlas is a natural comet, strange in its chemistry and orbit, but still a child of nature. This explanation may sound unexciting compared to exotic alternatives, but it carries weight. History reminds us again and again that nature is more inventive than our imaginations. What once looked like anomalies often turned out to be extreme but natural expressions of cosmic diversity. Take the example of Oumuamua, the first known interstellar object. Its cigar-like shape and unusual acceleration stirred speculation of an alien craft. Yet most astronomers today consider it natural, a shard of rock shaped by forces we don't fully model yet, perhaps coated with ices that sublimated in unexpected ways. Or recall Shoemaker Levy 9 inches 1994, torn into fragments before slamming into Jupiter. The sight shocked the world, yet it followed the logic of tidal forces. At the time, some whispered of mystery. In retrospect, it was textbook gravity on dramatic display. These cases remind us that strange does not mean supernatural. It often means we have more to learn. For 3I divided by Atlas, the natural but strange scenario suggests it carries ices uncommon in our system, perhaps nitrogen or exotic organics, frozen in distant interstellar nurseries. Its hyperbolic orbit is not evidence of control, but the simple geometry of a visitor unbound by the Sunday. Its green coma, though dazzling, may trace back to carbon molecules fluorescing in solar radiation. Even the flickers of light, possible glints, could be shards of dust reflecting sunlight like broken glass, not signals of design. In short, the weirdness may be real, but the cause could still be natural physics and chemistry. This scenario has a reassuring quality. It says, the universe is vast, and diversity is expected. Just as travelers bring back souvenirs from foreign lands, interstellar visitors may carry chemical signatures rare to us, but common elsewhere. The shock is not proof of artifice, it is proof of variety. A wine taster, sampling vintages from new regions, may encounter flavors unknown to their palate. That does not make the wine artificial, it makes it surprising. So too with 3i divided by Atlas. Its strangeness may simply be the taste of another stellar kitchen. Why, then, does this explanation matter? Because it grounds awe in reality. If 3i divided by Atlas proves natural, it still reshapes our understanding of how planetary systems form, what materials survive interstellar travel, and how common such travelers may be. It gives us a data point for modeling the galaxy. Each interstellar visitor, however odd, adds bricks to the foundation of cosmic science. The boring explanation is not boring at all. It is the slow work of turning anomaly into knowledge. And yet, patience is key. To confirm this scenario, scientists must see repetition. Are the spectral lines consistent across nights? Do different observatories report the same ratios of gas? Do the comet's dynamics follow natural models when refined with new parameters? Each confirmation builds the case for natural but strange. Each gap leaves room for alternatives. But here again, reproducibility rules. One telescope's surprise does not define the comet, multiple confirmations do. For the public, this scenario offers a lesson in humility. The natural world is often weirder than fiction. Waiting for confirmation may not satisfy the hunger for drama, but it feeds something deeper, the wonder of seeing nature reveal its subtleties. To embrace the natural scenario is to say, I do not need the universe to be artificial, to be amazed. The cosmos itself, in all its untamed diversity, is enough. So the first path remains open. 3i divided by Atlas as a comet, natural but strange, no less fascinating, no less worthy of study, but firmly within the family of nature. And in many ways, this path is the most powerful reminder of why we study the skies at all. Not to chase only what is alien, but to learn to marvel at what is already real. The second scenario is less comfortable but deeply compelling. 3i divided by Atlas as a natural object with persistent anomalies, behaviors that strain the boundaries of what comets usually do. In this frame, the star witness is the so-called glint. Reports of sudden flashes of light, brief but sharp, have begun circulating among observers. Could the comet's surface be reflecting sunlight like a mirror? Could it be shedding sheets of ice that act as prisms? Or could these signals be mere artifacts of sensors or satellites streaking across the field? The questions remain open, but the possibility forces attention. What exactly is a glint? In simplest terms, it is a spike in brightness that occurs when sunlight reflects off a smooth surface directly toward an observer. We see it in everyday life. The flash from a windshield on a highway, the sparkle of sunlight across a lake, the blinding twinkle of a phone screen catching the Sunday. Satellites like Starlink are infamous for producing glints, visible as sudden streaks against the night sky. Translating this concept to 3i divided by Atlas, the claim is that parts of its surface or fragments around it may produce similar reflections. The intrigue arises because comets are typically rough and dusty, not smooth like glass. For a glint to appear repeatedly would be unusual. This is why scientists outline strict criteria. For a glint to carry weight, it must be 1. Repeatable. One flash proves nothing. Multiple flashes, at predictable geometries, suggest real structure. 2. Independent. Observed by different telescopes, in different locations, not just one instrument. 3. Consistent. The brightness and angle must match models of reflection, not random noise. 4. Excludable. Alternative explanations like satellites, atmospheric distortion, or sensor glitches must be eliminated. Without meeting these criteria, a glint is gossip, not evidence. With them, it becomes an anomaly worth explaining. But even if real, an anomaly does not equal artificiality. Smooth, reflective ice sheets could form naturally, especially if 3I divided by Atlas carries exotic ices unknown in our system. Dust fields can align, creating mirror-like planes. A tumbling fragment can flash like a signal, though it is only physics at work. To leap from glint to craft is to mistake puzzle for proof. The middle scenario says, let us admit the anomaly, but refuse the shortcut to sensationalism. Consider parallels in science. Pulsars, when first detected, emitted radio beats so regular they were nicknamed LGM, little green men. For months, scientists debated artificial origin. Today, we know they are neutron stars, spinning corpses of suns. The anomaly was real. The explanation was natural, but astonishing. So too may 3I divided by Atlas's glints, if confirmed, prove to be signals of physics more creative than we expected, not signals of intent. This scenario teaches patience. Because an anomaly is only a doorway, it does not tell us what lies beyond. Walking through requires reproducibility, cross-checks, and models. If the glints repeat through December, if they show up in independent datasets, then the anomaly will stand tall enough to demand explanation. Until then, it remains a flicker on the edge of vision, dangerous only if we mistake it for certainty. For the public, the temptation is obvious. A glint looks like communication, like intention, but the wiser view is to treat it as a test. Can we hold wonder without jumping to conclusions? Can we marvel at the flicker while waiting to know what caused it? This restraint is not anticlimactic, it is the essence of evidence literacy. The patience to separate anomaly from artifact is what turns astronomy into science, not spectacle. Thus, the second path remains open. 3I divided by Atlas as a natural body with strange reflective behaviors, a puzzle pressing us to refine our physics. Exciting, yes, but its value lies not in how quickly we declare meaning, but in how carefully we confirm reality. By the close of December 2025, the three scenarios for 3I divided by Atlas remain on the board. Natural but strange, natural with persistent anomalies, and the faint, distant possibility of something artificial. Each scenario has advocates, each tempts the imagination, but none has yet crossed the threshold of reproducibility. That threshold confirmation, across instruments, across nights, across perspectives, is the dividing line between what we hope and what we know. This is why scientists resist premature closure. A single spectrum can dazzle, a single glint can thrill, but one witness alone does not win a trial. In courtrooms, credibility rests not on the first voice but on the chorus, multiple witnesses telling the same story independently. Science is humanity's courtroom, and 3I divided by Atlas is on the stand. Until the testimonies align, the verdict cannot be given. The public may hunger for resolution, but resolution without reproducibility is not truth, it is theatre. The virtue of reproducibility is not just technical, it is emotional. It teaches patience in an impatient age. It reminds us that knowledge worth having is worth testing twice, 3 times, 100 times. A tree does not grow taller because we shout at it. It grows because seasons repeat. A discovery does not become solid because we wish it. It becomes solid because it survives replication. In this way, reproducibility is not merely a rule of science, it is a philosophy of life. Do not trust what cannot be repeated. So, where does this leave us with 3I divided by Atlas? It leaves us in the space between fascination and finality. We marvel at its emerald glow, we puzzle at its orbit, we debate its glints, but we also wait. Each dataset now being processed may confirm or contradict. Each night of observation may strengthen one scenario or weaken another. This is not stasis, it is motion at the speed of truth. The comet itself moves fast, but our understanding must move slowly. The two speeds together tell the real story. Nature rushing past, humanity pausing long enough to know it rightly. For the audience, the invitation is clear. Resist the pull of hype, whether it insists on dismissal or insists on drama. Choose instead the middle posture, cautious, patient, attentive. Marvel at the possibilities, but withhold the verdict until the evidence repeats. This posture does not diminish wonder, it protects it. When the truth of 3I divided by Atlas finally hardens, whether ordinary, extraordinary, or unprecedented, we will be able to trust it, because it endured the trial of reproducibility. And perhaps this is the deeper gift of 3I divided by Atlas. Not just a comet racing through our system, but a mirror reflecting our habits of mind. It asks us, can we honor uncertainty without rushing to fill it? Can we let patience be part of our awe? Can we, in a world that rewards speed, still value the slow rhythm of truth? The comet itself is indifferent, but our answer will reveal who we are. The universe is not silent, it is a traveler, sending messengers across gulfs of time and space. In just the last decade, we have received 3 such messengers, each slipping into our solar system unannounced, each leaving as suddenly as it arrived. Oumuamua in 2017, elongated and strange, sparked whispers of the unknown. Borisov in 2019, more ordinary but no less historic, proved that interstellar comets are not myths but realities. And now, in 2025, 3i divided by Atlas, Emerald and Enigmatic has become the 3rd guest in this unfolding cosmic trilogy. The hook is simple yet profound. If 3 visitors have come in such a short span, a 4th is inevitable. And so we wait, not with fear, but with anticipation. This framing matters. Too often, our conversations about interstellar objects drift into extremes. Hype that leaps to aliens, or dismissal that shrugs them off as irrelevant. But seen as a series, these objects form a story. Oumuamua was the spark, Borisov the confirmation, 3i divided by Atlas the puzzle. Together, they are not accidents but evidence. The galaxy is porous, its borders crossed more often than we imagined. Our solar system is not a sealed box, but a harbour open to travellers. That realization shifts us from surprise to expectation. The 4th visitor is not a question of if, but of when, and this expectation reshapes our posture. Instead of asking whether anomalies will prove extraordinary, we ask how ready we are to greet the next guest. Each visitor teaches us more than data. They teach us attitude. Oumuamua taught us humility, to admit how little we know. Borisov taught us vigilance, to scan the skies more carefully. 3i divided by Atlas teaches us patience, to let anomalies settle into evidence before declaring truth. These are not just comet lessons, they are cultural lessons, shaping how humanity relates to the unknown. To stand here, at the end of 2025, is to feel a hinge in time. Behind us lie 3 visitors, each reshaping science. Ahead of us lies the promise of the 4th, the 5th, the many yet to come. The board is no longer empty. The game is underway, the cosmos has moved its pieces, and we are learning the rules. And in that realization lies hope. We are not isolated wanderers in a silent void, but hosts in a universe where visitors are real and recurring. The challenge is not to invent stories too quickly, but to prepare ourselves wisely so that when the next guest arrives, we can listen clearly, observe, and marvel honestly. Thus, the trilogy becomes a prologue. Oumuamua, Borisov, 3i divided by Atlas. They are the opening chapters of a longer saga. And the hook that begins part 8 is this. The 4th visitor is coming. The only question is how ready we will be to meet it. Now, as December 2025 closes, 3i divided by Atlas begins to slip away, its emerald coma fading as it races back into the darkness between stars. To many, its departure feels unfinished, questions still dangle, anomalies remain unresolved, and the comet leaves more mystery than clarity. Yet this is the nature of cosmic guests. They arrive without invitation, stay briefly, and vanish before we are ready. We do not control the timing, we only decide what to do with the traces they leave behind. And 3i divided by Atlas has left traces. Petabytes of raw data, spectra, and light curves are stored in archives around the world. Observations of possible glints have been catalogued for years of analysis. Models revised, recalibrated, debated. These traces may not yet spell certainty, but they are seeds. In the coming months and years, researchers will return to them, mining them for insights long after the comet is gone from the sky. A guest may depart, but the footprints it leaves on the shore remain, waiting for others to study. Its legacy is not only data, but discipline. 3i divided by Atlas arrived in an era of hyper-accelerated information, when every anomaly risks being swallowed by rumor. Yet the scientific community resisted the pull of haste. They mapped scenarios, tested hypotheses, and insisted on reproducibility. In doing so, they modeled a posture that may prove more important than any single discovery. the ability to hold awe without surrendering to hype. This, too, is part of the comet's gift. Culturally, 3i divided by Atlas reminds us that wonder does not require immediate answers. Awe can coexist with patience. The comet's green glow, its hyperbolic escape, its possible reflective flashes, all of these are beautiful, even without definitive explanation. Just as an unfinished symphony can move us with its fragments, so too can 3i divided by Atlas inspire without closure. It shows us that sometimes mystery itself is the treasure, the spark that drives further searching. More practically, the comet has already changed how we prepare. Telescopes are being upgraded, surveys expanded, and data pipelines refined. The community has learned the value of rapid yet rigorous coordination, ensuring that the next interstellar visitor will be tracked more thoroughly, with fewer gaps. In this sense, 3i divided by Atlas is both teacher and catalyst. It leaves us wanting more, and better, and faster, not in conclusions, but in capabilities. For the public, its legacy is subtler but no less powerful. It has drawn millions into conversations about science, skepticism, and wonder. It has revealed how quickly rumors form, but also how communities can learn to ask sharper questions. It has been shown that ordinary citizens, armed with evidence literacy, can become part of the defense against hype. In classrooms, in forums, in podcasts, 3i divided by Atlas has become a case study in how we navigate uncertainty. Its impact, in this way, may ripple far beyond astronomy. So while the comet departs, it does not leave us empty-handed. It leaves us with data to analyze, tools to sharpen, and habits to cultivate. It leaves us with the reminder that science is not a race for instant closure, but a discipline of endurance. And it leaves us with a vision that each visitor, no matter how brief, enlarges the human horizon. This is the paradox of cosmic guests. They arrive suddenly and leave swiftly, but their true stay is measured in the years of study they inspire. 3i divided by Atlas may fade from the sky, but it will live on in journals, in classrooms, in the minds of those who watched it streak by and wondered. Its departure is not an end. It is a handoff, passing the torch of curiosity to the future, to the astronomers who will study its traces, and to the public who will wait for the next arrival with wiser eyes. If 3 visitors have already come, the 4th is certain. The only question is when and whether we will be ready. To think of the 4th visitor is to imagine the future as a harbour. Ships have already entered, surprising us with their sudden sails on the horizon, but the next time, the harbour will not be unprepared. We are building lighthouses, strengthening docks, and training crews. In other words, we are preparing not for speculation, but for welcome. On the scientific front, preparations are already visible. Surveys like the Vera Rubin Observatory are designed to scan the entire sky nightly, capable of detecting faint travelers at earlier stages. Space-based telescopes are being planned with wider fields, sharper sensors, and pipelines able to flag anomalies in hours, not weeks. The lesson of 3i divided by Atlas that coordination matters has spurred new agreements between observatories, ensuring that data is shared, not siloed. The 4th visitor, whenever it comes, will not catch us quite as unready as the first 3 did. It will find an audience equipped, eager, and better armed, with tools of patience and rigor. But preparation is not only technical, it is cultural. The arrival of the next interstellar guest will again unleash a storm of speculation, from casual curiosity to wild conspiracy. What we learned in 2025 must guide us then. Evidence literacy is as vital as telescopes. If science builds better instruments, society must build better habits of skepticism, of patience, of discernment. The anti-hype mindset born during 3i divided by Atlas must mature into a cultural reflex, so that the 4th visitor is met with wonder and clarity, not confusion and noise. This dual preparation, technical and cultural, is what makes the vision of the 4th visitor inspiring rather than intimidating. It says, "We are not passive watchers of the sky, helpless before mystery. We are active participants in the story of discovery. We can refine our instruments, yes, but also refine our collective character." The cosmos is testing both. It asks whether we can wield sharper tools and steadier minds at the same time. And here lies the most hopeful thought. The 4th visitor may arrive sooner than we think. If Oumuamua came in 2017, Borisov in 2019, and 3i divided by Atlas in 2025, the cadence is shortening. Perhaps the galaxy is more crowded than we assumed. Perhaps we stand on the edge of an era where interstellar messengers are not once-in-a-lifetime events but regular chapters in science. If so, the next generation will not only know of these visitors, they will grow up expecting them. And that expectation could shape a new culture of curiosity, where children look at the night sky not only with awe, but with readiness. What will the next visitor teach us? So the fourth visitor is more than a comet. It is a vision of preparedness. It is the symbol of a future where science and society move together, each learning from the last surprise, each better equipped for the next. It is the hope that we can meet mystery with wisdom, not haste, with humility, not hype, with unity, not division. In that vision, the next arrival is not just another rock. It is a milestone in our growth as a species that learns, remembers, and prepares. The harbour is being built, the lighthouses are lit, the crews are trained. The fourth visitor will come, and when it does, we will be ready to greet it not with reckless speculation, but with open eyes, sharpened instruments, and the patient wonder that 3i divided by Atlas has taught us. In the end, the story of 3i divided by Atlas is not about a single comet, but about us. It is about how humanity chooses to face mystery, with haste or with patience, with fear or with hope. The comet's green glow may fade, its path may carry it beyond the sun's reach, but the questions it ignited remain. And those questions are gifts, reminders that we are still beginners in a universe far older and larger than our imaginations. The vision of a fourth visitor is therefore not just scientific but human. To anticipate it is to admit that we live in an open system, a crossroads of stars, a harbour for wanderers. It means accepting that we are not isolated, not forgotten, but connected to the wider galaxy by streams of rock and ice that cross the void. Each visitor is a knock on the door of our cosmic home. We cannot choose when they arrive, but we can choose how we open the door. Will we fling it open recklessly, or will we step forward with calm, with readiness, with gratitude? This choice belongs not only to astronomers, but to all of us. Every person who asks careful questions, every teacher who encourages evidence literacy, every student who resists the lure of easy answers contributes to our readiness. The hosts of the cosmos are not only scientists at observatories, they are communities, classrooms, families who learn to greet mystery wisely. In this sense, waiting for the fourth visitor is not passive, it is active, a discipline we share. We prepare by sharpening our tools, but also by shaping our culture. And this preparation carries hope, for in a fractured world, the sky offers something no border can divide, a shared horizon. When the next interstellar traveller arrives, it will not belong to one nation, one institution, or one ideology. It will belong to all of us. Its light will shine on every hemisphere. Its data will challenge every scientist. Its mystery will inspire every child who looks up. To be ready for the fourth visitor is to be ready for unity, however brief, in awe. So let this be the message we carry forward. Patience is not emptiness, skepticism is not cynicism, and wonder does not require immediacy. 3i divided by Atlas has shown us that awe can be richer when tempered with discipline, that mystery can inspire even without closure, and that the future is not a void but a promise. The fourth visitor will come, and when it does, we will stand not as frantic speculators, but as careful hosts, offering our best instruments, our best minds, and our best spirit of welcome. The comet is leaving, but the invitation remains. It is an invitation to live not in fear of the unknown, but in anticipation of discovery. It is an invitation to practice patience as a form of strength, to see reproducibility as a philosophy, to treat evidence as the true language of awe. Above all, it is an invitation to hope to believe that the universe is not silent, but speaking, and that we are learning, slowly, to listen. And so, Part 8 closes, not with an ending, but with an opening. The trilogy of visitors becomes a prelude, the harbour is lit, and the hosts are waiting. The fourth guest will arrive, and when it does, humanity will be ready not with perfect knowledge, but with open eyes, steady hands, and hearts prepared to marvel.